Test, test.
We've got a picture, we've got audio. We must be ready to go. It's Tuesday night, at least in this part of the world. So therefore, it's Keshe Plasma Reactor Group. So yeah, I'm Rick Grammond, and let's start the Keshe Plasma Reactor Group. So let me see here. Let me get my sound properly. And I was just greeted by Pia. Hi, Pia. How are you tonight?
I'm cool. It's morning here.
Oh, okay. Yes, I got to be careful when I say it that way. That's true.
Yeah.
Let me see. I see, Doug, your video's on. Did you mean to have it on there? Because it gets recorded otherwise. And let's see. Red Dog, would you like to be known as Red Dog? Or would you prefer another name?
Tim is fine.
Okay, Tim. Tim has some questions regarding what he thinks are basic things, but I suspect once we get into it, it won't be so basic after all. Because everything can get complicated pretty quick in this realm.
I hope it's complicated
Or
because
simplified quickly as well. So,
maybe I'll sound smart if it's complicated, but I don't think so. I have been listening to quite a few audios and videos, and there's the copper oxide GANs, which I've created. I've created the nanomaterials, and CO2 GANs I've created. But for some reason, how to create the CH3 GANs has eluded me. So is it just a nano copper plate with a copper plate? What's used to create it?
The CH3 is the same process you did with your CO2 and your copper oxide, except for instead of using copper or zinc, you use iron. Just use like a 6-inch untreated, uncoated spike, metal nail spike. Like I use 3 of them at a time, and it works really, really good.
along with a copper oxide plate, though.
Or a nano copper plate.
Yeah, that's a nano copper plate.
Oh, okay. So a nano copper plate and iron.
Right.
Yep.
In salt solution.
Yes.
Okay. What was I hearing?
Also.
Say what?
You can use steel wool also.
Okay, that's a good idea because that would act very quickly.
I was going to say, but it'll respond quick.
Yeah. It has a lot to do with surface area, it seems, and
yeah.
And steel wool or scrubby pads are great. The copper scrubby pads I've used, and they can be quite effective. But yeah, steel wool, geez, that seemed like almost instant.
For folks that don't understand, steel and iron are essentially the same thing. It's just steel is iron with a really low carbon content. The only difference.
Yeah, I wonder if it really is steel wool or just iron wool.
Well, if it's iron, like if it's like proper elemental iron, it's powder. you need a low carbon content to get it to stick together. So
yeah. Okay.
You know, if you look at pig iron, which is about as pure as you can get, it's if you hit it with a hammer, it just comes apart.
Yeah. Yeah, I just use nails.
I just use untreated, uncoated nails. Say that again.
Do they have no? It would be sheep iron. They have pig iron. Iron for steel wool.
I've got a cat I'd like to hit with some iron.
No cat jokes.
No.
We'll have all the cat lovers hating us.
Oh well, that's only because she runs across my keyboard. But all right, well that'll work. That helps. What is? I've heard mention of sugar in using it in creating some type of GANs. What's that doing? Or did I miss that totally?
Sugar.
Yeah.
If I remember right, the Chinese folks were experimenting with that, and they're finding that sugar works as well as salt.
Oh, really? Okay. I
haven't tested it, so I can't endorse it. I can't explain it. I don't know, but
Right.
it's an electrolyte, right, in the
Right.
water,
Right.
pretty much to allow
Right.
the flow of the ion.
It's
So I think
also
it's feasible.
Well, I tried it for 24 hours, just a sugar solution with copper plate and a copper nanoplate, and got nothing. But of course, you know, the copper oxide tends to respond slowly anyway. But
what solution was it? How strong was the
oh, yeah, I wish I knew. I'm not even sure how to figure that out for the salt solution yet.
spoon per cup or
I
tablespoon?
actually I went. It was probably a tablespoon per cup, and I went up from there until I was tired of adding.
Yeah, that seems like a pretty strong concentration of
Yeah,
sugar.
it was very strong when I was done.
I thought it was that a little bit of sugar gets added to certain combinations in order to sort of add a bit. So you look at sugar, what is it? Well, generally it's I think it's C12H22O11.
Yeah,
So it's your basic CHO combination, which is all useful things when broken down in a solution for nano coating in a way. Have your
yeah.
oxygens there and hydrogens, and the carbons can be useful as well,
Seems
depending.
like it would be helpful somehow.
And if everything's really hot, in fact, sugar is a type of nano coating. If you just use sugar and heat it up, it becomes like a syrup, and then coat it on something and keep heating it, and then it caramelizes or it turns brown.
Right.
And then after that, it turns into carbon. It turns black and
Right.
becomes the black form of carbon that we know. But it also nano coats the surface and will actually form certain nano coating depending exactly how it's done and so on. And you can get some very exact structures using it's a carbon nano coating process.
Mm.
I was going to use maple syrup actually and do that. And I actually accidentally nano coated the bottom of my my biggest pot that I normally use. And well, let me get it here. I'll show you just right back.
Yeah, I've done the same thing making caramel.
Yeah, to go back to your previous question about the concentration, I just did a video with Carrie Ellis last week, and we set up an entire Gans factory. And the concentration I wound up with really, really well was a half a cup of salt, just regular table salt, in 6 cups of water. So that worked out to 8.3%. And the Gans is coming out like gangbusters on this setup.
Wow. Okay.
Like a good percent. I go with you're talking about regular salt in the salt solution. Is that what you mean?
Yeah, just Sifto white table salt.
I go with 100 grams per liter, and that's not 10%. It's more like probably around 9 point something percent, small, low nines or something. It seems to work pretty good, and it's easy to remember. I like that part. Anyway, this is what it looks like.
Oh yeah, pretty.
You know, everybody burns the bottom of their pans every once in a while or whatever, but and so it happens, and you usually can scrub it out, but this one was particularly bad, and it had I think it was jam in this one actually. And when it burned in enough that I could not scrub it off. I've been at it well for off and on for weeks basically, and trying to scrape it with a spoon and all the scrubbies and different things and combinations and salt and vinegar and everything else. And this stuff is really embedded into the surface. This
What's
is
the pot made of?
just sitting on top. This is stainless steel. It's got a clad bottom.
Have you tried caustic and aluminum?
Caustic and aluminum are good. It's a good way to eat holes in your aluminum pot.
Hey, you just
But
want to get
actually,
rid,
no,
you want
it's
to
a
get rid of it,
good
right?
combination. You think about it, because what happens when you put caustic into aluminum? If
Yeah,
this was an aluminum pot, you
yeah,
get hydrogen.
right.
Okay, so if you get it all boiling and it's hot, and well, that extra hydrogen is going to add to the temperature. And I was just reading how if you're going to grow a nano crystal, like say this was the surface of the actual nanomaterials, because the copper could actually look like this in terms of its structure, a bunch of pyramids or other types of structure. And what was I going to say about that? That if you were to add the like this kind of thing can actually make that kind of structure with the carbon, but you can do the same thing with copper with a certain temperatures and regulating it to get a pyramid type nanostructure, for example. And they do that with sugar. So if they do it in the lab with sugar to actually create a certain particular nano structure, then it makes sense that we could use that perhaps as part of at least part of a heat process. And with the caustic, in a way, it is a heat process too. So,
Well, I brought it up. Mr. Keshe mentioned it
mm,
for blowing the nanomaterial off of your copper plates when you want to do over. He said just put them in caustic with aluminum, and the
yeah,
hydrogen helps blow the
usually,
nano
yeah,
coating off. And it
yeah,
works too.
you can take aluminum foil and ball it up and put it in along with your
Yeah,
mixture, and that generates a lot of heat. In fact, it can be
yeah,
quite dangerous if it's in a closed
yeah. No
closed
smoking.
bottle. You don't want to do it inside a bottle and put the cap on. That's kids do that, and they throw them and they blow up. Basically,
Yeah.
happens. And
Well,
so you need
I
always.
don't want to hog the meeting here. I want to move
No,
on
if
to
you got any more questions, go ahead.
yeah.
It's
Just real quick, Mr. Katz mentioned several weeks ago about someone who had put together a document on making the various nanomaterials, and I think he even mentioned the Gans materials. He mentioned the name Benjamin.
the name what?
Benjamin? I don't
I
know
think
who
that's the
that.
fellow. I think that's the fellow that's working with Alex in Africa.
Yeah.
I
But
haven't seen the doc. I don't
okay,
know.
Yeah, I haven't seen that yet. No.
okay.
Benjamin is in working in Ghana, and he wrote a book on nanomaterials, but it's not out yet.
Oh, okay.
Thanks, Brent.
That'd be nice to have when it comes out. All right. Next question was when you're polarizing your wires or whatever. Once you have your nano coating, several coats on it, should you expect to not get a reading? In other words, the meter on the ohms stays at 1, or should you expect to get 0.00?
Wait a minute. Just say the question again there.
Okay. When you're polarizing your coils or whatever your nano coating, and you're in the stage where you've steamed and now you're going through drying, and you put a positive and negative on it, should you expect to get a 1 on the meter on the ohm setting, or 0.00?
Okay, well, if you have a proper nano coating on, say, copper at least, then you should have a basically zero ohms or
Right.
infinite resistance, or very, very high 20 megohms or more resistance.
So a 1 is not good, because
Well, if the meter doesn't read, if you put it on your nano coating and it doesn't do anything, that's telling you it's infinite resistance.
that's good.
It's essentially a short circuit, or essentially an open circuit. It's a piece of plastic. there's no flow whatsoever.
Okay.
Right.
But
No,
I
if
don't
it's
think
one,
using the resistance scale is the right way to do it. I think using a low DC voltage scale, because that allows any of the ionization that's in that structure to flow out
I
rather
agree.
than putting more in.
Yeah, I agree. You know, it just seemed, you know,
yeah,
it
but
mentioned on several videos to put it on ohms, and I was like, well, I don't get this.
well, the thing is, you can put it on ohms to check your nano coating to see if it has. It should have no. It should have infinite resistance. Should have no conductivity on the actual wire that you stick your leads on.
Right.
Right. So, or or coil, let's say,
Right.
put it on one part, put it on another part, even if it's right beside it. If it's perfectly nano coated, it'll still be no conduction. That's why Mr. Keshe and others were able to put their hands right on the coils, right on the nano coated coil while the device was running and not get a shock from it. Because
So how,
if you did that with bare copper, then you'd probably be on your butt on the floor.
yeah, how is the 1 ohm meter different than the 0.00 if one is?
Well,
Well,
when
if you
you're getting 1 ohm.
No. When you turn the meter on and your probes are apart,
Right.
you just do a 1. It's over on the left side.
I get 0 and dot L.
Okay.
Maybe you get a 1.
I get a 1. Yeah, and then when you touch it to the nanomaterial, do you get something other than that?
Well, sometimes you can get a ranging kind of thing.
Right, I've seen that. Yeah.
Some random
Especially
stuff.
when it starts drying.
If it's a really good, solid coating, it'll be just like. Well, I don't have an example right here in front of me, but I've got. Well, actually, I do. I think. Got this.
Yeah. Pretty.
Nano-coated crystal.
Is that a hole in the middle?
Pardon me?
No. It just looked like you had a hole in it. I was going to ask you how you did that.
No, that's just a spiral at the end.
Okay. And
normally it you could clip on with alligator clips or something. I actually put a 1/8" phono plug at the end of this, and I was experimenting with just plugging it into the audio on my computer and that kind of thing.
Oh, okay.
But I had it inside a container. It's been nano coating for several months basically.
Right.
Let's see if I can get the computer a little bit. Wait, there we go.
Were you nano-coating with the crystal? Or without the crystal?
The crystal was part of the package, yeah. It wasn't a heavy steaming. It just had a bit in the bottom that was, but it sat in this small container for a long period of time. Let me make my screen bigger so you can see. Okay. Maybe that's better. Okay, so second, I can zoom in a little bit here, I think.
Yeah, I admit I have a cheap meter, so it mostly because I kept hearing that after a while your meter's going to die. Using it on
if you short your leads out, you'll get 0 because there's 0 resistance. Right now he's got overload, which means that it's an open circuit.
All right, gotcha.
So I've got like 0.1 or something there, and it should it'll zero itself out eventually.
Okay. All right.
So let's just try this.
Yeah, it's doing pretty much what mine does.
Yeah, essentially an open circuit. But this is something that a lot of people have missed with the reactors. You're taking a device which is essentially an open circuit, putting it in line, and then stuff after it is still running.
I know.
Nobody picks up on this.
I picked up on that right. I was like, holy cow.
I mean, every single one of these devices works.
Yeah.
If you put it in your system and you plug a drill in and your drill runs, it works because,
Yeah.
you know,
It
That's
has to be something
weird.
other than the
I had to
electron.
push really hard, and I broke through
Yeah.
the coating. Like I'm pushing really hard there right now.
Yeah.
I'm
If I scratch through the coating, I'll get a
still
reading.
not doing it.
yeah.
Quite amazing. Let's see if the crystal gives any reading. No.
What do you suspect you would get when you measure your plasma capacitors?
Just a second here, my
That's a good
It
question.
should have the same thing. It should read as far as the electrical system goes. It should read an
say
open
that
circuit.
again. If I'm on capacitance, is that what you
No,
said?
the plasma capacitors, when you check those out to see if they're working properly, what are you expecting to see?
I would expect the same thing, wouldn't it be?
Yeah, you should see an open circuit in a resistance measurement.
Yeah. Now, what do you get when you change yours to DC volts, Rick?
Well, that can be interesting, I think, usually.
You should have a little bit, just a very light voltage jumping around. That's what you
Yeah,
should have.
that's, yeah. Come on, jump for us.
Well, his coating, that's a very, very fine coating. So if he has any matter state electrical in there, it's going to be very small.
Mm-hmm.
And you got to remember also the resonance of that crystal is going to be absorbing a lot of it too.
Yeah. Okay, well.
Let's try the AC voltage just for.
No, that'd be, yeah.
Yeah, that's just spurious in the room, probably.
Yeah. Well, that answers that question because that's been driving me, I couldn't quite work it out in my head, but in terms of what to expect. So appreciate that. My next question was, I know Mr. Keshe, and I've seen, he's talked about ping pong balls, using them for reactors, putting Gans in it. Is there a reason for plastic? Could glass be used?
I don't see why not.
Yeah, I use a little Christmas ornament.
That's exactly what I'm using.
Yeah, that works fine.
It took me forever to, I had to use caustic to get all the stupid paint off. I couldn't find clear ones. But, the motivation.
I think it depends what you think is going on in the center as well.
That's why I took the paint off. I wanted to see if there's something going on in there.
What level of, what gradation of energy is happening and so on.
Yeah. So, okay. Cause
like, for example, when we were looking at rotating reactors at one point.
Yep.
Back here. We're looking at just rotating reactors. And if you look at glass, for example, something like this that would be rotating, and if you had stuff on the outside trying to either direct rays in or fields in or fields out through glass, then the glass can transform or block. For example, ordinary glass will block UV rays, and there's certain rotating structures where you want the UV rays to be able to go into your center structure as part of the ionization initiation of the reaction and so on. And there's other examples where you don't want to have UV rays coming out of your unit that could be dangerous. So you'd want to have a regular type glass rather than a borosilicate glass, which allows the UV rays to go through. So depending on which way you want it, whether you want to block it or allow it, would be the two different kinds of glass, for example.
Well, I guess the big question is, will a free plasma exit glass?
Oh yeah.
Okay.
My assumption is that the plasma fields will go through any of that stuff.
Okay.
Well, does the plasma? Excuse me, just a minute here.
It's always fun when Rick turns his toys on.
Oh yeah, yeah.
plug in here. I think I got too many devices. Ah, yes. There's a mouse tail. It doesn't need to be there. Ever wonder why they made USBs plug both ways? And they're at the back of a computer. It's not much fun. All right, so there's a plasma inside of here. We call it a plasma ball, but just as an example. And but the plasma itself, as far as the gases go, stay inside. They don't squirt out, but yet we can definitely influence the gases even without touching the actual, just have to come close in order to, influence it.
Right. So the plasma is reacting to the external forces. It's just the gas that's allowing us to see it is contained by the glass.
So there is a field. There's definitely a field, right? And I measured the field of these to be about, I think it was about this distance. There's a demarcation where the field goes like this, and then suddenly it increases at this spot.
Wow.
Okay. So all around this,
here's your force field.
There's a force field around these little plasma balls, and the bigger ones especially. The bigger ones, it's a little further out, but it's also, you can go along. I use my little crystal radio sensor here, my trusty little crystal radio, and plug it into computer audio, and it can hear the fields, right? So I can, if I have this set up and this set up, then it'll go crazy from all the fields, and you can hear it when it's properly set up, that at a certain spot, the fields increase. And also I've measured it with a little field meter doohickey as well. And on my iPhone, they all measure the same increase in the field at a certain point. And it's very interesting. It's actually less right here than it is out here. Strangely enough, you'd think it'd be just a gradient that goes stronger to the middle and weaker as it goes out, but no, it's got a definite gradient outside the sphere. In fact, I'm being impinged by it right now.
I can feel it.
I wonder if that could be some sort of an interference pattern coming off of that, because that is AC, right?
Yeah.
Well, they do have, they have a little circuit inside and so on that creates, I think, a multiple frequency sort of, it spits out, I think, maybe a series of frequencies, like boop, 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 something like that, to cover the gases and make sure they all get ionized and that kind of thing. So interesting. Anyway, I've read that 1% of the gases are ionized in these plasma ball thingies.
All right. Well, all right. I'll keep using the glass because, like I said, I just wanted to see if there was some kind of action or activity inside the Gans. Is it moving? Is it jumping? Is it swirling? Is it sitting there quietly? What's it doing?
It sits quietly a lot, it seems.
Yeah.
It's hard to get Gans to dance.
Actually, it's very, very good morning, good afternoon to you.
It's actually very easy, you're about to say, Mr. Keshe.
Yeah.
It is very easy because what happens, this is what now, first of all, why your interference increases on a certain point outside of the ball is because at that point is where your magnetical and gravitational field of the system interfaces with the environment or the earth. It's like we have the earth, and then you have the atmosphere, and then you have a certain point ozone sphere on the top end. That's where the actual balance between the two fields come. And that's what you get some distance away from the ball. You get the maximum, what do you call it, noise, or in whatever you're looking for. This is that's what actually what we call the ozone sphere, the top atmosphere of the, or interaction of the fields of the ball with the atmosphere of the house or the earth.
And it would be a similar thing with the Magrav's unit.
Yes, Magrav's unit have a much further distance. Sometimes small balls interfere 10, 20,000 kilometers. This is depending on how is that. You have the same thing with the Magrav balls, but when you put equal interference between different Magrav balls, you create a condition in the center where we call the free plasma. The plasmas, even which is created, we see on the interface of the fields, do dance, do move, do rotate. We can dictate the speed of the rotation. We can dictate the speed of the spin of the fields. The fields, there's a very nice video put in by a Dutch guy past couple of days where he shows in his CO2 kit where he has a copper plate and a zinc plate, normal CO2 kit, in the dark, and as he just accidentally shines light on it, you see the rotating Gans of the CO2, which is just faint, just a shimmer, and the rotating Gans of the amino acid on top. In the new instrumentation we are looking for, because this is what the Innovation Center is working on, is that we don't have any tools to measure the strength of the plasma.
Yeah,
At this moment of time, we have nothing. So what I have advised the Innovation Center that are working on is two things. The speed of the movement of a plasma in the vertical condition, and the speed of the rotation of the rings, which is created by plasma itself. What this means is that now we're creating new tools to measure the plasma we create, which is the real interaction of both gravitational and magnetical, and not just the magnetical or gravitational. There is no indication, there is no measurement tool, because it's by observation. So what they are doing in the Innovation Center is, in a way, piling up a load of ganses and allowing them to create their own motion. And then we are interfering with the fields of these rotational fields which are created in the container, and see how the strength of the plasma interacts, speeds up or slows down the rotation, and how in the container will move up or down, because these rings are not steady. They float. So the flotation is strength dependent in respect to the environment, and the speed again is dependent on the field strength of the environment too. So what you see as the point of interference with a ball in the hand of Rick, which comes certain distance away, this is not a steady point where let's say 10, 20 centimeter, half a meter away from the ball, you see a peak. That's the rotating. These plasmas continuously rotate. You look at it as a static. One of the reasons you see different lights on different points of the ball continuously, which is changing, is because of the phase change, the rotation change of the plasma. At a certain point, plasma just crashes up and charges up. So at that point, you get continuous float. It's not as they connect to ionized point, they connect to the what they call traffic jam of the fields which are rotating. The field around the ball, which Rick shows, is rotating at the speeds which we have never measured. We do not know these kind of speeds. is beyond the imagination of the man. So now we are trying to scale it up. Next maybe year, 2 years, the Innovation Center will come with a more detailed, what do you call it, measurement tools to measure a plasma. not by electron vibration, but by plasma motion itself. So it's a direction which now we are looking at, and a couple of people in the Innovation Center are working on. So these fields are not static. When you start thinking about the plasma, never think on a static condition. This is what's happening there. This is the combination of the rotation of the very fast fields and very slow fields. Fast fields are the magnetical, which are escaping. Slow fields at that point are where magnetical field has the maximum strength. And then when they find a balance with each other, with the environment. And at a point of interference, half a meter away, is where the, what do you call it, the balance fields between gravitational magnetic fields of the plasma of the system interferes with its environmental gravitational magnetic field. And these rotations now are a point of research and development for the new tools of measurement. So you got to, I try to encourage people to, what do you call it, start measuring the speed. These speeds and the change is the cause of the heartbeat of the man, of the planet, or the universal heartbeat. Because they switch. The switch comes when they what do you call magnetical gravitational in a equator line, I call it, or in the pole line interact, and one has to switch at a faster speed, a different gravitational magnetic field strength. And where you find it imbalanced with the environmental, this is where you hear the noise. It's a clicking noise. This is the way your heart works. Heart itself has a rotational field around itself, from what you call it, when you look at it from what I call for its equator, and it has a gravitational magnetic field rotation, which is a condition of its polarity. I explained this a long time ago. A lot of people have a misconception about polarity is just to do with the North Pole and the South Pole, but actually there is a polarity on the equator too. This is where your fields turn clockwise as anti-clockwise. The misconception in the science is that you only have one direction, but you have actually a balance point which is on the equator in the center. And one of the things we can explain in the imbalance between the emotion and physicality of the man is the position of the heart. It doesn't sit straight down, it sits in an angle. The heart is not positioned, what do you call it, in line with the center line of the body of the man. It's twisted to the side because of undue to equator pressure. Plasma has two motions. It's not that it goes underneath and it comes up from the entry to the exit. It has the rotation which we have seen too. We don't see these rings in the plasma going from the bottom of the pot to the top of the pot all the time. They rotate in the horizontal line in respect to the line of the Earth. And this creates rotation, this creates positioning, this creates forces. And how the heartbeat, you can actually, there is I did a study some time ago that in respect to the position of the heart in the body of the man and the heart attacks and emotional effects. These rotation of the fields in the body, which is what we call the heartbeat, we look at it as a heartbeat, but it's actually interference between the equator line plasma and a polarity sign, where at certain strength they click, they create field forces. This is what we're trying to change, or we're trying to bring into effect. I explained this in some of the teachings, where now in the Innovation Center, as part of their work, they started this years ago, but now we got involved with them. We looked at a few months ago in taking the engine out altogether and connecting the plasma power units directly to the car and directly in the line of the what we call the wheels, where we force plasma changes in interaction of the polarity and the equator line of the field to create field forces on the wheels that we don't need engines. We have had some success. We see some development. At the beginning, it was just, now it lasts a little bit longer, a few milliseconds, the motor goes. So it's the same way. This is how your heartbeat works. The interaction of the equatorial, which is the clock or anti-clockwise rotation of the fields, and the polarity rotation from north to south, or what you call south to north. Partially, these fields affect the strength, and where you can control the polarity change and the equatorial rotation, this is where you can create field forces. This is the cause of the rotation of the planet. 90% of the rotation of the planet field forces, which dictate it, comes from the interaction of these two, sometimes 90 degrees in line, or what do you call it, different rotation depending on the environmental field forces, makes them to rotate. These fields which you hear the radio going off or getting stronger, if you understand it and bring it in, is the cause of the lights in different position in the ball you see. And it's vice versa in what is thought. We see it every day. A heartbeat comes from it. The rotation of the planet comes from.
Does our heartbeat change in space?
Not really, because it's dictated by the body of the man.
That's what I thought.
It can slow down. It can slow down. It can be partially because of the atmospheric. Don't forget, your heart works in a total vacuum condition. Your heart works. Your chest is a vacuum environment. It's not an atmospheric environment. So you already work in a vacuum, and the body is made of the Gans. If you look into rotation of the whole solar system, if you look at the rotation of the fields of the galaxies, you see this. This is one of the reasons galaxies have structures which we see, because in different points, according to the number of the planets or stars or small miniature galaxies within the galaxies, they create locational, both gravitational and equatorial pressures, which in a way funnels the fields upwards. And because there is no structure in holding totality, we see most of the galaxies in a point where there is a height to it, there's a point of exit to it. If you, in the future, scientists draw the total fields of a galaxy, you will see it's not very far from the spherical condition of the planet. But in that position, it's just like squeezing cream out of a tube when you press a toothpaste. The field forces force certain strength, and the galaxy moves itself through the environment of the universe. This is what is part of a new understanding of the plasma. This is part we have to teach in the coming time. And if scientists understand this, maybe we bring this up in the teachings tomorrow, that now that people start making these crystals. The crystals are so rich, showing everybody is looking for dimension of going from the South Pole to the North. But if you look, the way we have put the ring, the middle ring, the center ring, is a massive dictator of the position. Massive dictator. But people don't look at it, just look at the big and the small. In the Innovation Center, they're creating 3-ring sets, which the two top and bottom are like a third size of the center core to create a fully spherical plasma control system. Brennan showed me the thing a couple of days, early last week. So in a way, for example, if you take a 14481, you move to 1/3 in a position of further up and 1/3 to the position further down. That the total field makes a spherical field flow in the center, but at the same time it creates an equatorial line of field forces. This is why we get a sphere shape out of plasmas. This is why we get a spherical planet. No one in the world of science ever considered the equatorial rotation, what you call equatorial clockwise, anti-clockwise of the plasma, is the dictator of this point of the shape. These are the things which we're teaching in the coming terms and coming time. You have a weak point, you have a strong point on two polarity side, but the rotational field in the center distributes the fields between the two ends, and where the balance is, it creates the physical shape of the structure. It's not that how. Ask yourself a simple question. How come a field goes from one end to the other and doesn't go in a what they call tubal shape or what I call cylindrical shape? Why everything is spherical? Because there's a second field force which has never been considered, which is what we talk about it, but we don't understand. It's like what I would say, we are nanoscientists, but we actually we made the nanomaterial from the day we were born. We are part of it. We are Gans. We never knew, and we made the first nano when we barbecued the first meat millions of years ago. No one stands still to ask, where does the shape of the planet come from? Where does the shape of the stars come from? Where does the shape of the universe come from? Because there are two field forces. One is the flow, and one is the rotation. The rotation creates the flow, but the flow itself creates its own rotation. So where you get a balance in respect to the maximum and the minimum and the rotation of the fields, you get the equator line. That's the maximum where the balance between the two fields. When a field goes through a body, plasma, earth, sun, whatever, because the body is made of composite fields, even the individual fields, there is a point where they find balanced field to move, there's a to exit, and the balanced move to come in. And somewhere between the two, you get a polarity rotation. But when you put the gases and the fields together, stacked up of different layers, they create their own rotation, what we see in the plasma. So the shape of the entity is dependent more or less on the field flow, environmental plasmatic forces, and the rotation of the field. And that gives the shape of the body, or what we call the spherical shape.
Can I ask a question about the crystal?
Yes.
When you drill a hole in the crystal, is an eighth of an inch drill bit type of size sufficient? How much CO2 do you have?
No, the thing is, the size of the hole is irrelevant. The people look at, you can drill to the thin wall of the crystal and fill it up with a gas. You still get the same kind of properties effects. The reason we put the CO2 in there is the CO2 interact with the emotion of the man. These are called peace crystals. We have actually registered it as a peace crystal. The reason for it is they emit, it's what I call monomolecular field strength. Because laser is a single, but CO2 is a composite plasma. So this plasma is, you increase the, in a way you put it in a shotgun and you shoot it up from the tip. So any amount will do. It's irrelevant of what thickness you do, but it brings monoenergetic, the fields which interact with the emotion of the man, which is part of it connected to the amino acid, which is COHA. The amino acid is not a violent, is not aggressive. Amino acids, which is the foundation, the building block of the structure, is a peaceful thing. And that peacefulness, when it comes in interact with a stronger matter, reacts, it's like an acid touching a metal, creates violent condition. And this is exactly why man is this, why creation on this planet is this way when it comes in touch with iron. It's an acidic interaction. It's a violent interaction, and then that violence has appeared in the behavior. So what you do, you, with putting the CO2 in the crystals, after using the higher energy, you reduce that strength of the violence. You reduce the gap between the strength of the amino acid and the field of the earth, whatever the matter, being iron, copper, is used to create the hemoglobin and the rest. They all look in the wrong direction. Physicality is irrelevant. We look in how the fields interact, what they do. Why do you increase the level of the physicality into the emotion? Because when it comes to balance, it finds peace. There is not such a huge interaction. This is the target of the crystals, and a lot of people are getting involved. What can you do with the dust of it? What can we do with the whole of it? How much gas we put in it? All we are doing, we are increasing the level, because it's a matter state gas in respect to what it creates inside it. We increase the level of the strength of the physicality to become more closer to the emotion, that you don't get the violent interactions of what we call aggression. It's nothing to do how much you do it, the way you do it, or whatever. Is in releasing in a much stronger end, lasering in a way, monomolecular structure. In the plasma or in the laser beam today, we go for monolight, monofrequency. This is a monomolecular field, which means it has a spectrum, is not, it has somewhere a strong spectrum between carbon 12 and oxygen 16 on the upper band of the both. In a way, we're working with, if you look at it, with a very top end of mono nitrogen, which allows the more division of the cells through what you call ultraviolet centralization in the structure of the plasma. It's literally what, if you look at the CO2 Gans in the crystals, we are looking very much like a B12 effect inside the body of the man. We bombard it, we release it, we let it absorb what is capable of absorbing because it's made of itself with a high level fields spectrum of nitrogen. Division of the cell, but in the emotional part of the cell, not in the physical. B12 interacts with the physical part division because it interacts. B12 itself, gamma, comes mainly from the matter state of the earth, of the structure of the body of the man.
You know,
With nitrogen, you work with the emotional part or the amino acid part, which is the peaceful part.
Excuse me. Am I correct in thinking that in the hands of a person, that these crystals will be as powerful as they are with the reactors? In other words,
much more if you know what to do with it.
That's what I thought.
Much more. What will be interesting in this research, which will come in the future, hopefully, is to see if we, for example, beam these fields, let's say, in a violent condition, aggressive condition, would it change the behavior of the animal or the man? Yesterday, just by accident, I haven't watched news for a long time, maybe a year. I don't watch television because I don't find it about problems. And I was just sitting with Armin, and we just happened to watch, what it came up is that they closed 1,000 schools in Los Angeles area, blah, blah. And immediately to the people is the fear mongering. This is trying to exacerbate the fear part of the man. We saw the same thing in near Vatican in Rome a few weeks ago. We've seen the same thing around Paris and around the world. If all of you could put these crystals in action as fast as possible, you'll find that these kind of behaviors, especially around the religious centers, will change. There is a reason for these suddenly high activities of allegations. When I disclosed very recently that the bodies which were found in Paris were never died in Paris, they were brought in from Palestine, they were brought in from Syria. It created a lot of problems with security people because they knew we were talking the truth. Because we've seen the replication of the same thing again and again. They use the mass media. Why don't we feel the strength in the field of the mass media and put it there that when the mass media creates this kind of thing, people find peace with themselves. They don't accept it. It's very easy. This is the purpose. At the moment, why don't we get these things in Southern Hemisphere? We don't get this in Japan, we don't get this in China. Why only in the Western nations? Because they're playing with the emotion. So with these crystals, if this is what I said last week when I showed the crystals, and nobody apparently understood, is to elevate the physicality to the level of the emotion. And everybody's looking just at crystals and this. No, because at this moment of time, there is a structure. There's a huge fight in Vatican. And that huge fight with the amount of finances available to them is how they can diminish the power and bring hatred between races and religions that we can control. Don't forget we have a Monsignor on the payroll of the Keshe Foundation at the high level in Vatican. We are aware of the movement within Vatican. It's a big dogfight within inside. And one of the things is someone to go the peaceful way and someone to create more wars that they have powers. There is a reason we are in Italy. We balance the fields, and in time we'll change the field. Now it's this crystals. Everybody is looking. We call it the peace crystals, and everybody is looking for energy. This is a monomolecular plasmatic field. If you can keep your crystals free in a way that you could sit on a, let's say, a free rotating base, you will see the crystals start rotating. Not, or if you make a big enough cylinder of the gas that it can float, you will see the plasma inside your crystals will start rotating on its equator. The field forces created is immense, but you got to remember something. You're still again looking on the wrong position in respect what I put on the table. If you create the right amount of fields and put very little Gans in the cylinder instead of you going with the human behavior of having the maximum, put very little that you can detect. And when you put your system on, watch where this ball flows between the polarities. This is the game. This is what you got to understand. Then you see how much strength you're adding to the release of the field at the level of the emotion of the man. I call it the emotional gauge. You can only give as much as they are prepared to receive. But if you make it available enough, the hunger will be satisfied. Because you look for the maximum. And some people understand what I say and they do what is going to be done. Don't fill in your hole with a tiny, what do you call crystal, don't drill a tiny hole in there. There are a bigger hole. But observe very little gas. Enough that you can observe, light enough that the initial fields of your coils can interact with, watch the speed of rotation, and watch its position. Does it go to the top core or does it go to the bottom core? Is it receiving or is it giving? Is the emotion of the people in the environment watching it, even yourself? It's the gauge of lying to yourself if you're a giver or taker. Are you emotionally stable? This brings a lot of people to understand a lot of things about themselves. These are the new, I said, we bring out new tools with the plasma technology. And I'm gradually walking you into it. You hold this core in your hand and put the crystal bar in the middle and see where that little bubble stays. Are you emotionally stable? Are you fit enough to be a man of space? Or does the crystal, the Gans inside the crystal moves to the North Pole, which means you're a giver? Or does it go to the bottom and you're a taker and you're a liar and you cause problem because you take everything you want? And in taking, you have a behavior of animal. Or would it show the elevation of the soul of the man except to his emotion? People just get carried away with a little thing, and this is how I brought the technology. You just walk into it. But these, in time, even I explained to Arman and Alex when we were in the lab last Saturday together. I explained to them what is the purpose of the crystal in the space motion. They both understand. And they understand what we have to do, what will be as part of the control of the flight system. Don't forget Armand is a master in these things. And Alex is crazily master, more than in so many ways, in his ways. They have two beautiful souls, and you can teach the soul. I don't, with these two, I don't teach the physicality. They understand the essence, and it's beautiful to work with them, where everybody else is looking for physicality. You spend 10 minutes, 2 hours with these two in the lab, because to understand the emotion of the plasma, understand the physicality of the plasma behavior in its own dimension, it's just working in different dimension with these two. But all of you look for fields and look what's the size of the hole. Crystals, behavior of the crystals, change the CO2 and put a Gans of meat in it. And then you'll see the behavior and the aggression will come out of all of you. It's a judgment tool, I call it. A lot of people will have fear to handle it because they don't want to know truly what they feel or how they are inside. Very, very interesting. Time to come for these things. Sorry about this, but this is part of what you got to learn.
So by expanding that concept, if we were to put, say, CH3 in the crystal, we would have then an energy wand. Is that correct?
In so many ways, yeah.
Okay.
Yes, because you got to realize if you do this, you become creator of violence. It creates a lot of violence. It doesn't create energy that you think I'll have more energy. Don't forget CH3 is an interaction with the plasma of the Gans of the body of the man. So you increase the energy inside, and at a point you go back into the same position as aggression.
Okay.
You understand? That's why we don't recommend it. If you create a condition between the CH3 and CO2 and add to your structure, because you don't add to the structure. As part of the process, the way you produce CO2 with the zinc plate, which you have managed to create the gas of zinc oxide, which is part of your CO2, and you put it in a double wall container and you drink it, you will have one of the most powerful Viagras. Yeah, it's been tested. It works. But the thing is, can your body handle it, or would you kill yourself with it?
Yes, there's
The
been a lot of
CH,
people who've been experimenting and having some rather, how would I describe it, intense reactions.
yep, because CH gives the energy. CO2 balances the emotional part of the brain, and the zinc oxide it triggers the strength of the sexual emotion. Is one of the most powerful Viagras you could ever touch, but it's a natural process. But again, is the intention with your partner. You're there to give pleasure, to elevate the soul with pleasure, or you're there to elevate your own physical interests. Yeah. If it's the second one, you always fail and say it doesn't work. But if you are there to increase, to give, you'll find out the partner enjoys, and you behave totally different. This is what I was talking to Alex about. I said, it's strange, it doesn't work on some people. I said, you got to look at the intention. Yeah. Because the intention is self-glorification, where when you make love to a lover, to your partner, you do that to please, to give. That's what we call it, making love. Love is giving. if people understand, you put in the crystals a mixture of the CO2, CH3, and zinc oxide, you find people will be like, what do you call it? 1960s. Sex and what do you call drugs and rock and roll. Because every energy is there.
Okay, that makes a lot of sense. Thank you very much.
You're welcome. We know it doesn't make sense. We know it's working because we've seen people doing it. A lot of people. You can, I was talking to Alex. Alex says, he says, I've taken it a step further. I put the orange on top and put some honey on the orange. And the love tastes so sweet. So you can play with the dimensions of it. You got to look at the fields of strength. You got to look at the look at the plasma strength that you create the minimum field difference. So you have to elevate the physicality to reach the level of the emotion or become closer, that the emotion and interaction of physicality does not bring violence. This is what I've been telling for a long time. In the coming time, we can bring a condition that no man remembers why they're carrying guns with them. Yeah. What's the reason of violence? You can do with the fighting, or you can just create as many of these plasmas and peace crystals, and then you'll find out. If you add CH3 with it, you're going to run into a problem, because the energy increase will be on more or less the matter energy combination because of the physicality absorption at the lower level. CO2 is very high, CH3 is very low. It's only 15. The other one is 45, 3 times more powerful. You can put CH3 on one end of the crystal and CO2 on the other and create the rapid expansion or rapid departure. What do? You put your CO2 at the bottom and you put your CH3. And as the nature of the universe is giving to this weaker to bring balance, so the field flow is much faster. You create what they call a shotgun.
Yeah.
This is a lot to play with. A lot of you looking, if you look at the, what you were just talking about, the spherical cores, placing these spherical coils, crystals, and then you will see the fields will flow. The flow of the fields come from the motion of these crystals because they increase the speed of the rotation. You can do it on a, what they call the equator line or on the polarity line. Just, you don't need to go inside it, just place crystals outside. As long as you don't disbalance your system, you will see different performance. Because you're looking for the, you think you put the Gans inside and you're looking for the matter state of the interaction of the Gans inside. But as Rick showed, there is more fields outside than inside.
So would it make sense to have a lighter Gans on your coils and a heavier Gans on your crystals outside to direct that field flow in towards?
Why? We'll discuss this tomorrow, because Dutch people have raised this question. Why don't you wash your Gans from the dust and spray your coils with it? Put as part of the Gans. You know, when you put the Gans on your coils, add the dust of the, what do you call it, crystal to it. You will see totally different performance.
Yeah.
Because you create, in a way, randomly, you'll create a directional flow.
Right.
We are looking at this in the medical section, health aspect.
Yeah, the directing of the field flow, the field forces is very interesting to me. I've got several people that I'm talking to who need targeted field energies, and I'm trying to come up with some way that they can simplify or very simply do this. Um, and it's getting clearer as the more I think about it.
Depends what you want it for. What is the intention of use? From now on, whenever you endeavor in anything to do, especially with the structures of the Gans and systems which uses Gans, don't look what the system can do. Look what is the intention of the use. This is part of the structure which man one day will understand. We're trying to explain it, but somehow he overshoots it everywhere. Is if you're
well, and I'm working on the emotional aspect of that, but I'm also looking for some sort of a tool that he can use to help mitigate this a little bit until we can get into the deeper aspects of his issue.
What do you mean by medicate what?
Mediate or just to mediate his issue, just to take some of the weight off of him, the stress and the issues with being constantly.
Who's speaking? Who's speaking and what?
This is
What's
John from British Columbia.
Yeah, but what are you trying to do for who?
It's a young fella named Anuj. He's bedridden. I think it's multiple sclerosis, and one of his issues that's really pressing right now is he can't absorb water. And it doesn't matter how much he drinks, he is constantly dehydrated. And I'm trying to come up with a way to be able to infuse the energy of water into
Are you a
his system.
physician? Are you a doctor?
No, I'm a tool maker. I'm just giving him some insight into the plasma, because he's very interested in using the plasma. He's
Yeah,
using CO2 right now.
yeah, but
Go
the
ahead.
thing is, with MS, he has to find the center of emotion.
Yes, we
You're
realize
dealing with
that.
the tools. You're dealing with the tools, but not the end product.
Yeah, we understand that, and I've been discussing that with him. His issue started when he was very young, when he was 3 years old. So the emotional aspect of this is very deep seated, and he's having a really hard time finding even clues as to where to look for this.
No,
And a
the
lot of
thing
the
is, you don't
problem
look
that
for
he's
the
having.
clues. Let me tell you, you don't look for the clues. Just 1 second, please.
Okay.
Yeah, everybody's there. My son just woke up. You got to, with MS especially, you got to look at the source of because I've done a lot of MS cases, numerous numbers over years. In MS, you got to look at, not to find a cure, not to find a solution. You got to look at the expectation, emotional expectation. And where they find the answer, you'll find them they start improving. Where, as long as they, in their subconscious, think they're missing or they've been done wrong to, especially by the mother, yeah, you'll find you have a huge problem in getting it done. Good morning, little boy. Good morning. Good morning. Yes. Come. Hello. Okay. So what it is the expectation which causes this problem. Thinking not being given enough or been done wrong too. If you go that way, you'll find out they have and they just start walking. When they realize there's been no problem, it's me who, or my emotion, who was expecting 2 cups of water, but I received 1, but I actually had 3, but I ignored the other 2. You understand? This
Yes,
is
I
the
do.
problem with MS. And so, because I didn't get the 2, the 1 I was expecting, but I actually received 2, so I'm not prepared to walk to get the 1 I think I'm missing, but in fact I received 2. And that's why I'm not prepared to go and get it. Means I'm going to physically not walk, physically not move my hand, physically sit there till somebody bring it to me, because I'm still expecting for the 1 I'm missing, but I've got 2, but I'm ignoring it, denying it. You have to allow them to enlighten themselves. This is the problem with MS. What I call, they are habitual thieves, which has become so much that they become self-centered. And where does the sense self-centering comes? I'm not prepared to do, I'm not prepared to walk, so you took so much from me, so if I sit down, I'm paralyzed to give me what I was deserved, which I didn't get at the beginning. This is why we see this behavior with MS. What is paralysis? Why do we lose? You have to look at the psychological reasons than the physical. Physicality, when you see paralyzed or whatever, is the end product of the physical reaction, is the end product of the emotional behavior. I've been done wrong too, and I've been done so much wrong too that I'm sitting down till I get my share. I go paralyzed. That's all it is. But if you elevate their emotion, their understanding, that they realize that they're not missing anything. They actually instead of calling other people, they've been thieving themselves by hiding the extra 2 they got, but they never accepted. Then you find out 2 positions. They kick themselves, or they start resenting themselves, or they take a step to correct it. And it's usually the first. But they don't admit it. And if they understand it, you see them walking. I can show you a video of people who've been paralyzed on a wheelchair with MS, and they walk, they cook.
Oh, I think we lost him.
It's not wrong with me. Pardon?
Oh, you cut out there for a sec after cook.
Yeah. So what I do, I replace me instead of the mother, and they expect me to become the giver of the emotion to confirm themselves they're not thieves. And when we walk away, we see them stop moving. They go back there because I become the mother instead of the mother they've used but they denied. But with me, they get it through the system, the emotional support. And usually, I've tested this. When I stop seeing them, paying them attention, the improvement stops totally. So the improvement is not system dependent, is attention dependent. You understand?
Mm-hmm.
And
Yeah,
because they are, but I call them, pardon?
it appears this thinking would fit with many different autoimmune diseases. Slight
All
differences,
of
but
them. With MS, with ILS, with what do you call a part of the Alzheimer's.
Mm-hmm.
The ones which are not genetically inherited, Hello. Hello.
You're here.
We got a long research into MS, long research. But I think one of the best things to do is, like this, what I explained earlier with the crystal, with the Gans in it, put it in their hand, see if they are the takers or the givers. If they are the takers, and this is this behavior of the MS people usually, is the gas will move to the bottom entry point of the fields because they want to take as soon as it arrives. Make yourself a crystal, put it in a 3-core ring, and give it to him to get him to hold it and observe where the gas sits. It tells you a lot about the inner motion. I did this with the knowledge seekers in the Sansana. I put 2 detectors literally on top of each other. We have a powerful sensor detectors, and one is for high and one is for low. And I sat the students in front of it, kneeling on the ground, literally sitting on the ground. And this system connects to the computer. And we see the field flow. I touched this last week or the week before in the teachings. And I got all the students to sit in front of this for half an hour, whatever it took. And I gave them instructions to give and to take from the environment. They never understood. I call them the judgment tools in a way of understanding themselves. There was a guy who pretended to be very wise, very generous, very whatever. And when I put him inside, I put him in front of the machine. I decided he's not there to stay. You could see his habit was to take. He was not there to give, but pretending to be giver. And very interesting, the facial structure, when you look, it gives a whole idea how the behavior is. I put all the students in front of it. And those who were in structure balance are the ones who are with us. They are givers more than takers, and they share without consideration what they receive. Those who I saw the the behavior, what it was, they left very early. Very early, because when you sit in front of these systems, one is gravitational and one is magnetical, and they are both looking in the same direction of the field. So when you tell to give, can you give as much as you like? You should see the high flow in the field, which is the system which is looking into you. But what actually see the system which is looking away in receiving end is more active than the one downstairs which is supposed to be receiving. And you see the behavior pattern. And that electronic device in the crystals will be the same. Because your emotion is the center between your physicality and the soul. So the gauge moves. the Gans will move. Because if you're a giver, you elevate your soul. If you're a taker, you go more into the physical side. Because that's your physicality. Give him one crystal with a core in his hand, and then you'll know what you're dealing with. Then you know if you're wasting your time or not. Sorry about that. I listen.
Well, thank you very, very much. That was certainly helpful.
Yeah, they got to find out a lot of the MS people. The name sounds like Iranian name to me, but a lot of these people have a problem in understanding the reality, and it's what I call ADD, attention deficiency, which increases to too high.
Has anybody online actually drilled one of the crystals yet? Or have figured out the tools needed to do that?
Oh, it's the same process as drilling glass. You can do it with a number of different tools. You can use a grinding compound and a piece of brass. You can use a hole saw, diamond hole saw. You can use a carbide drill bit if you grind the tip properly and go really, really slow. But it is a very slow process.
You got something there, Rick, you're going to show? The special tools you got?
Find my way back to the mute button there. Yeah, this is something that I picked up. I'll be trying out, which is a 1/4 inch glass and tile bit.
Do you think that will go through the crystal?
I think so.
Oh, that'll
I
work.
saw online where they had these drill bits that have holes in them that are specially made for gemstone drilling. And it looked like it was, you needed the high-speed drills versus a regular drill.
Right, so I'll use this in my Dremel tool and see how that works.
Yeah, just keep it cool. Keep a bucket of water and wet rags handy. Peck drill, go in, get a chip, bring it out, go in, get a chip, bring it out. Don't expect to go more than about 1/2 millimeter a minute.
Right.
You're dealing with a very, very hard, very brittle substance, so you got to be super gentle with it. And the round cylindrical drills, like the hole saws, there was a fellow on the Skype that was bringing that up earlier. They would work if that center plug actually snaps off when you get to the bottom, but you don't need to, like Mr. Keshe said, you don't need to drill a hole that big. You know, 1/8 of an inch is probably plenty. And the smaller the drill, the easier a time you're going to have poking a hole through that crystal.
And
Cutting the end off on a tile saw will do really nicely to cut the end off.
have you tried it on a tile saw?
Well, I'm a tool maker. I work with all kinds of different materials, and from what I know of the structure of the crystal, this is how you need to work with it.
Yeah, I've heard you can use Dremel diamond encrusted saw attachment as well.
Yeah, you just need to keep it cool. Keep it, do it either under running water, or make sure the crystal's wrapped in a rag, a wet rag. Keep it cool, because if you create a temperature gradient within that crystal, just like glass, you're going to induce a lot of stresses in that, and it could just shatter in your hand.
same with vibration. So maybe you might need a rubber tip device to hold it, for example.
Yeah, a good solid setup for sure. A drill bit, or a drill press or a lathe would be the best way to go. If you have to use a Dremel, mount your Dremel on a little skid so that you can just slide it back and forth, and it always hits in the same spot. If you try to do it by hand, you can do it, but it's going to be really difficult.
I've been playing with another idea.
Or grow it on a piece of
Instead
wire.
of drilling the hole,
Or grow it on a piece of wire.
grow the crystal around the wire or around the Gans or whatever you want to have in the center. So
Yeah.
I've been playing, in this case, this was grown in a day using borax, nature's freshener. So this is actually has boron in it, boron crystal. So I thought that could be interesting, and it's an easy way to grow crystals. So I experimented a little bit with my my little dragonfly, which I've normally used with a battery and a magnet, and it sits there and buzzes and rotates and so on. It's made out of copper wire, and the spring is down to the bottom. It's completely encrusted in crystal, except it is it's also somewhat hollow. See through it. It starts to close up, but you can actually see right down through it.
So that would be like a borax crystal?
Yes, that's right. It's borax, which is, what do they call it?
So I think that there's a difference between a quartz crystal and a borax crystal or other gemstones.
Can I give you a tip?
Yes.
Can I give you a tip? In a different direction. Don't forget, I have a long history of diamond cutting.
Right.
When I used to be a diamond dealer, but from the source to the cutting to the setting and the rest of it. We noticed when we had a very pleasant, very calm diamond cutters, we used to have the most beautiful cuts. When we had angry cutters, then we had the cutters who were there just for the job of it, not for the pleasures of creating beautiful stones. We always had a problem. The stones crack, the stones break. We call them trouble cutters.
Trouble cutters?
And I used to have a, pardon?
Trouble cutters, is that what you said?
Troubles, yeah. Their emotion was the trouble. The way they behaved, yeah, they created problem all the time. There was always something wrong. So I don't know if you've been to diamond cutting offices. The diamond cutters, usually one or two, work in a like an air capsule. They work in a safe which is locked up, and they go in and it gets locked up, and on it maybe 10, 20 rotating blades. And all they have to do is just keep an eye on the cutting. These people are always very aggressive because it's a job. Mass cutting diamond is just, it's different than when you have a single man sitting and cutting. In Antwerp, they work this way. You have the cutting officers, or you have diamond cutters, which is a single man. You give him a stone and you give him 3 months, 4 months to cut a stone. He won't cut it for you in 1 week. Bigger stones takes months to cut properly, because he takes a stone, he works on it, and when he doesn't feel good with it, he puts it aside, he cuts another stone. And what happens is, when you cut these stones, even when you get a drill in your hand to cut, cut it with emotion, with intention. If your intention is to bring peace, to bring a balanced field, you'll find out you can put it at highest revolution you can, it still goes through, because you connect to the stone. You don't need a wet cloth. I've tested this and it works. If your intention just to get through to see how it works and I want to do this, you find every stone shatters. The crystal is the reflection of your emotion. When you can work with the high, you can low with slow. Don't forget, I'm an engineer. I work the same as our friend as a tool maker. I worked on the lead machines, and I've got 2 or 3 understand exactly what I'm talking about. The intention will give you the stone you like, the hole you like. Before you touch a stone, before you cut a stone, pick it up, feel it. If you are in tune with it, the stone is the crystal which goes to reflect your emotion. If not, pick 2 or 3 crystals. Immediately you understand this. I used to do this as a diamond dealer. I pick a stone, I feel the stone. I never had to look inside the stone because of the video cutting. Crystal, you find 20 crystals and you shatter every single one of them. You pick a crystal, it feels light. It feels, I'm happy with you. That's the crystal you need to cut, not any crystal. And when you cut it, you have to have emotion. You collect this energy and you give the energy to when it needs it. You can cut it at any speed. We tested this with the diamond cutters and it works. If you sit on but next to a diamond polisher, very cool, it does the last.
Hello, Mr. Keshe. I think we lost you there.
Yep. Definitely an enlightening evening tonight.
What did you grok out of it in particular, John? Is there something you want to speak of on that?
Well, it just, as he was talking about the emotions and cutting the crystals, it brought to mind one of the things that I learned very early in my doing tool and die work is if you're stressed, walk away. You can't do good work if you're not loving what you're doing. And it really came out in the work when I was at work or when the other tool makers were there and we're singing and we're having a great day. Our finishes were beautiful. Our fits were perfect. Everything just worked really, really well. When the place is noisy and some guy comes in and he drops a plate and startles us all, we notice our work quality drops dramatically. And that's, it's kind of a really gross demonstration of what he's talking about, but it's the same thing.
That kind of holds for almost everything.
Yeah, no, but crystals are different. When you work with diamond edge to cut metal, you work different. You feel different.
Yes, very much.
Am I correct?
Very, very much. When I was doing diamond grinding, it was a completely different attitude.
Crystals have a different behavior. The Russians have done a lot of work on this, in their tool, because they work a lot with the diamond powders and that kind of thing. But it reflects your emotion. when you angle a tip of a cutting blade and you touch the noise, the emotion tells you it's just wrong. It's just wrong.
Yeah.
The tool tells you before the minute you touch, and you pull it back, and you just there is no scientifically everything is correct. It's the emotion you put into it. It's the same with crystals, and nobody understands this because they only look for the physicality.
Yeah, I noticed a very similar thing even with different types of steel, whether I was working with D2 or H13 or O1 or even like 1018 mild steel. The feeling of the steel was different. And it took about 10 years of doing this, but I could walk up to the material rack and pick up a piece of material and pretty much know whether it was hard, whether it needed to be hardened, what kind of material it was, if it was suitable for the job I was doing. I didn't have to do any testing on the materials. And it was a very interesting thing. I noticed that when I'm working with aluminum, I have a certain kind of a mindset. When I'm working with steel, I have a different mindset. When I'm working with carbides or beryllium or any of the different types of materials, they do feel different. So it's very true. I've experienced it myself.
I tell you stories. This happened when I was in Tehran. When we were making a specific system for a flight in a part of the Sharif University, we needed a steel, a special steel for us. And I'm always in tie and suit, even in Tehran, which is very abnormal. And I was in the factory where we were cutting the rings. And I heard cursing. And then this happened a couple of times. I walked to him and I said, what's the problem? He said, the steel you want doesn't cut. I said, let me look here too. Let me see the cutting. To him, just you're using it the wrong way. Your intention to finish the job to go home quick. This needs a lot of attention to do the job because it's for peaceful purposes. He said, you don't know. And this still would not cut. He had a, what do you call it, the toughest diamond edge in, and it was so.
We lose him again?
Yeah, you're breaking up there again, Mr. Keshe. Your signal is breaking up, that is, not you.
Gentlemen, this is Sylvester Belser from Hungary. I really appreciate all these beautiful informations. And Mr. Keshe, if you hear me, sorry, but I need to go. I really enjoyed your teachings today, and God bless everyone.
No.
Sorry, you want to do what today?
Oh, Sylvester's just saying he needs to get going and get set up for the teaching today. He's in with the core group in Italy.
Oh, okay.
No, sorry. I'm in Hungary. I'm in Hungary right now. I'm gonna have a meeting today, 2 o'clock. But in the morning, I need to take care of some things. I have some appointment, and I just said that I really appreciate all the beautiful thoughts. And Mr. Keshe, thank you so much for your teachings today. And unfortunately, I need to leave the group right now. But thanks for everyone, and God bless.
I see. Okay, thank you, Sylvester.
Yeah, it's definitely true. And it doesn't matter what you're doing, whether you're sweeping the floor or doing dishes or bathing your dog, it all matters. I mean, the attitudes. There we go. Oh, that looks so nice, Robert. That's the drawing that I had up. And that's a beautiful, beautiful piece of work. Is your mic working? He doesn't, well, his mic's on. Oh, you're still muted.
Can you talk?
How come it's so red? Can you tell it's so red?
Oh no, that's not a photograph. That's a technical drawing made in SolidWorks.
Mm. I thought it was a coil.
Yeah, it's pretty accurate, isn't it? Nice. Huh.
Because that fit.
The number of turns aren't absolutely accurate. He was having some issues with getting the right number in SolidWorks, so he just made it fit. And it's primarily the reason why I started working on this. I started working on one in AutoCAD, and I was having issues with it, and Robert took over. This is for the manufacturers, so they can have a 3D model that they can take apart, look at in any way they want before they start winding coils, and it will help the manufacturers significantly in designing their processes.
Can you guys hear me?
There he is.
Did you choose the colors of the two rings separately? Or
No, what
color?
I tried to match the colors to these existing drawings.
Yeah, but is you know, the inner core. If you go back to the original web picture, the inner is slightly darker color than the ring.
Yes.
Is that on
Rotate
purpose
it,
or just?
rotate it so we can see down the end of one of those coils, Robert.
No, you see, if you look at this ring, the gravitational ring is different color than the magnetical. Is that by color choice? Or is it
Yes,
the same color?
that's to differentiate them, but so it would be easier to see. Basically, I just tried to copy the same color scheme here, so people who were using these 2D drawings can see the same color scheme in the 3D model and not get confused, you know?
Yeah, but the reason I asked the question, because in reality, especially when you do the heat treatment nano coating, the center coil always goes very purpley blue when it's totally magnetical, or sorry, totally gravitational, but magnetic outside.
Yeah, we
And
can
when you
apply.
heat treat the color, by the color, you can see that.
Yeah, we can apply any material we want to these models. It's just a model.
No, it's just I was explaining gravitational rings. I thought if the color was coincidental, but in reality, when we do the heat treatment, I can post a few pictures, which is taken from another coil set. The gravitational rings, when you look at it, is dark purple. It is perfect gravitational. With the color of the rings, we can say whether there is a problem in coating. People have a number of coating with the gas coating.
Yeah, we can make it any color we want. This was just for wiring, as a wiring to help people with their wiring of the coils. Hello?
Beautiful, beautiful work, Robert.
Thanks, John. What I might do is come up with twisted pairs of wires to replace these connections. So it would look more realistic of what people should be doing, twisting them together.
Yeah, that's a good point.
And the SolidWorks had a limitation of 100 turns maximum of these coils. So the outer ones are 100 and the inner ones are what was it, 62. Basically the ratio would be 1.618 or 1.62.
You have to advise the coil. We see what we found out is 144 and 81.
Yeah,
is one of the maximum field strength systems.
Yeah, what we can do is make a table of the best combinations. And this is mainly just the wiring diagram. The main area would be the connection of the coil ends, but we can put a table or a note here indicating what the optimum coil ratios are and number of turns are.
Yeah, we can also with SolidWorks we can animate a particle traveling down the wire to simulate flow directions.
Robert,
Yes.
are you part of the animation team?
No, I'm not.
Do you work on your own?
I'm a mechanical engineer at the moment. I'm in between jobs. I'm working with a startup company doing hydrogen production. But I'm not part of any Keshe units at the moment.
You see, we need somebody with your with your knowledge. Get in touch with Vince through Webmaster. We with your knowledge, we need designers like this, especially on the manufacturing side.
Yeah,
if you're in between jobs and you're looking for another job or something you can support, that'll be interesting.
Sure. I was going to say
I can direct you to the people if you need help getting the contacts.
Okay, sure. But I've met with Armen here. I live in Los Angeles area, so I've met with Armen, and you know, he knows about me. We can also work through him. You know, whatever works.
Yeah, because he is the head of manufacturing, and we need people like you who understand. A lot of people draw pictures of these coils or whatever animation, but the way you have technically colored it, it means you have an understanding of the problems of the manufacturing or the manufacturers, how to do things. And this itself is an art of understanding, because technical drawings this way, especially three-dimensional, at this moment we need people who understand this like this. Simple drawings saves a lot of time for manufacturers, and especially training. These pictures have value for us, because this connects to where.
Yeah, this is why I wanted to get this project rolling. I started working on it with AutoCAD and ran into some issues, and Robert said, well, I do SolidWorks, I'll draw you one up, and there it is. It's beautiful.
Get in touch with Armin. You have his email, I presume, his contact. I'll speak with him today. We most probably meet later on for lunch or whatever. And I'll explain to him, because we need people who understand, especially when we work with different languages. There are so many factories to be set up. Simple drawings like this, it's a gift for teaching, because it's very hard to show what wire goes what there, but simple colors, and it seems to understand this. Helps a lot.
Well, I think Armen is going to be back in Glendale on 20th of December, what I heard. So I'll meet up with him.
He's coming back. Probably can speak to him tomorrow. I'll get him to get in touch with you, because we need this kind of, especially teachers who we teach, to teach to the factories. We are putting a group of teachers. This kind of animation makes life so easy. It doesn't need a language.
Yeah, that's as a design engineer, that's what we. Okay. Sounds good.
Very good. Thank you very much. But it's very nice.
Yeah.
We need a lot of support in this way. We need, pardon?
The other reason I wanted to make the 3D model was to do some engineering simulation on it, analysis, but I don't know what to use on it. Electromagnetic simulation, magnetic circuitry simulation, or plasma.
There's a plasma thing for SolidWorks, I believe, isn't there?
Not SolidWorks. There's flow simulation, but not electromagnetic.
Oh, okay.
But I can get access to software, but I'm still not sure what to use on it to get plasma type of simulation out of it.
You're just looking for a field visualization?
Not visualization and also field interactions, because this coil setup looks like a transformer, but I don't know if as a regular transformer it would be acting the same way as a plasma type of a device.
No, don't think so. I was just looking at a site that had listed the way plasma interacts, and they did experiments with it. They had a magnetic field that took a bend, and they had a particle, and the particle will follow the bend in the magnetic field. So they figure, well, if we shoot a plasma down this magnetic field, what will happen? Will it just keep going straight? Will it follow the magnetic field like the particle does? Or what will it do? And it turned out the plasma went opposite. Instead of turning with the magnetic field, it actually went opposite and went its own direction. It didn't go straight. It didn't follow the magnetic field. And much to their surprise, it went the opposite way. So I think we would have to use some sort of new software that's aware of that anomaly.
Yeah, I don't know if this will help, but when I look at this system, I kind of get the feeling that it's acting similar to an antenna, where it's actually absorbing. It's a resonant absorption of the fields. Again, my understanding is admittedly crude in this area, and I'm learning all the time, but that's the impression that I get from looking and playing with these systems.
But would the plasma build up into the circular inside the coils essentially and start rotating or something like that? Is that what you're
Yeah, that's what I'm visualizing is it's drawing the plasma in, encapsulating it into the inside center of the loop, like just like that Large Hadron Collider, and it's interacting with that singular wire that's running around the inside, or the singular nano tube that's running around the inside, and using that as a collector to move it to the next stage of the system.
Or as a collector or accumulator, perhaps, the way Mr. Keshe was talking about the nanomaterials, or the Gans rather, will start spinning essentially, and they can be spun up. And I was reading about some of these small particles that when they're spun up, they go into many billions of RPMs and then into the terahertz range, actually. And apparently they can store the energy just through spinning in the terahertz range. And if you add energy to it, then it'll go up into the next range and so on. So I think perhaps that's what happens with the Gans. When it's treated properly, it'll spin up inside and create a spinning plasma that can store the energy.
Well, they use nano-coated copper plates as sort of a solar, what do you call it? Solar energy plates, make solar cells out of them.
Yeah, you can use the red copper oxide. You can use a penny or a copper plate and create the red copper oxide, and that will actually, it's actually a solar panel just by itself, a crude one, but
So
inefficient. But yes, it can definitely work.
so it's absorbing solar radiation with the application of GANs over it, or maybe even without it, it could be absorbing other frequencies or other energy fields.
Well,
Definitely.
is it
So
absorbing solar radiation, or is it absorbing simply radiation that's brought in by the solar wind?
Right. And the one thing the test would be, does it work better at night?
yeah,
Right.
Is anybody
or
curious?
under the sun.
No, most people haven't been playing with their units at night, perhaps. I'm wondering if maybe they only work good at night.
Yeah,
Mr. Keshe's units, his initial battery units, um, just have to.
yeah, most units are probably indoors, so they don't see any sun. So it would be interesting to do an experiment to compare the unit under the sun versus at night indoors and see if there's a difference.
Because his batteries work best at night, right? So.
Very interesting.
Okay, I can stop sharing if you guys want to discuss.
It's so
other things.
beautiful, I could almost look at it all day. It seems like.
I'm gonna make the capacitors next,
Oh, great.
and
Excellent.
then maybe make a stack, 3-level stack, and make the connections of the stack.
It would be
If we can work
interesting,
out,
do you have the electrical induction program for SolidWorks or some sort of similar simulation?
I have, yeah, I have. It's not SolidWorks, but
It would be interesting
I
to
can
run some
couple.
simulations. You can couple it with a different app. Like, it would be interesting to see just the regular fields that are generated by a device like this.
Yeah, that's what I want to see. I just want to
use
see.
induction fields primarily.
Yeah.
It's an unusual configuration, yet it is the same. I was just looking at a picture of the Birkeland current, what's called the Birkeland current in space. You've heard of that before?
No, I haven't heard.
Well, Birkeland current is basically the way plasma moves through space. There's a current, just like the blue wire, in the central core of the reactor, and that's more or less the direct current that runs through. And then there's an AC current that runs around that wire. And then there's another field around that. So there's actually at least three fields plus the external environment, all going at once in this Birkeland current. And it's almost exactly the same concept as these coils. So this is part of the new electrical space concept, as opposed to the more the gravitational space concept that we've been led to believe up till the last decade or so.
Yeah, the other thing is the nano coating. Well, the nano coated copper is a semiconductor. So we're basically have made a coil from a semiconductor, and we have two coils that can interact with each other, and they're both like semiconductor coils, capacitors, so like a whole bunch of things together. And it's very interesting what kind of properties and effects it has, as you know, without even being having a GANs on it, or even being nano coated. Just the wiring shape as it is, what kind of effects it has. That's kind of interesting to me. So I'll probably load up one of those analysis programs and do some simulations of this, see what comes out of it.
Yeah, that would be very interesting, I think. Let me show the little thing on the Birkeland current here, and just to see if I can get this in the right spot. Oops. That, this over there, and so on. Now, okay, here's Wikipedia blurb on the Birkeland current. Mentions with the Earth's magnetosphere here, but it's actually through the whole, you could say through the entire universe. But you can see the picture here on the right. This is the magnetic field lines and the current path in a Birkeland current that may develop in a plasma. So what we have is this central arrow right down the middle, the black line going straight up. And then the red line around that, which is the field of that current, that is the black line. And then the actual magnetic field lines is like that blue spiral line. And then we have these other self-constricting magnetic field lines and so on, these green lines that are all part of this same operation. So when you have these currents going through a plasma, they automatically generate several fields at the same time, you might say. So we have rotating and more or less, maybe not counter-rotating, but at least co-rotating fields going on here. And that helps keep things in line and creates like a tendril of plasma as compared to a blob of it, you might say. Anyway, I thought that was interesting in the shape of our coils is very much the same in many ways, with the two coils inside plus the straight wire.
Yeah. Interesting. Are the red and the blue rotating in the same direction?
Yeah, there was a better picture I had before. I'm not sure. Maybe it's in this document. Yeah, I'd have to look through it and paw through it. Do that. But the way I understand it is there's the black line is like the DC current going through, and it creates a field around it and another magnetic field as well that's part of the this self-constricting magnetic field lines they mentioned. it creates its own Coulomb barrier, you might say, around that system. Similar to what we were speaking of earlier.
Is the green the resultant of the interference between the blue and the red, maybe?
I believe that's true. And it is an actual barrier, like a
force field.
Yeah, more or less. That's right. It's actually pretty important results that that these guys got. This was back in 1908, and the way they managed to find out a lot of these things is through actual laboratory experiments. So they were. Oh, that's interesting. Oh, that's very interesting. Here's a picture here, for example, that's shows the scientist Christian Birkeland in his Terrella. His Terrella, I'll find out in a moment, but it's a evacuated chamber. It's a vacuum chamber. So he put this magnetized anode globe. Here he has a magnetized globe in his chamber, and it creates these currents you see here. These light tendrils, you might say. So that's interesting inside of his Terrella. This Terrella was his Terrella is a magnetized model ball representing the Earth. You see, he's done a couple of experiments here with a ball inside of a vacuum chamber. There's this vacuum chamber there. You can see the experiments he was running. It's quite a large chamber, and he was running high voltage in it and so on, and creating these currents, these Birkeland currents inside, and tendrils and such forth. And he observed that there's similar in space, and he started a whole movement of lab experiments to judge what was going on in space. And that was one way they started working with it. And then they found through the lab experiments that plasma actually behaved differently than the way it's commonly seen in space, and they added new laws to it and so on as they did more and more experiments. Okay, so didn't mean to get too far involved with that, but it is interesting, and it's there's more to it than that as well. Okay. Says all such experiments are now been replaced by computer simulations. So we're on the right track, perhaps, with that. Okay. Okay, what else do we got out there, guys? What would you like
Thunder
to
egg crystals, Rick.
Pardon me?
Thunder eggs are crystals that are formed inside a hollow by volcanoes.
Right. Yeah.
Maybe something.
Quite interested in that right now, actually.
Yes, me too. Just thinking about drilling crystals and hollowing crystals when there are already hollow crystals. You know,
right. That's right. That's like my little guy here.
Yeah, exactly what made me think of it. There he is.
I've got a whole plate of crystals growing in here.
Yeah.
And I'm trying different combinations of wire coils, and I've got a coil here, for example, that's, you can see it started growing.
Yep.
Can you grow it in a like a mold or give it a shape?
Well, that's exactly what I'm experimenting with. I figured if I give it a shape of a nano-coated wire coil, does the crystal follow the coil all the way around? And in essence, it does. This is starting to build on various different parts of the coil. And it will have a more or less a hollow core at the end of it. And the crystal will be built out around the crystal of the nano coating, because it is a crystal that we're dealing with the copper. It's a copper crystal nano coating. So I think it's important what kind of nano coating we start with this kind of process, because different kinds of nano coating is it's the starter layer. It's the what do you call it? The seed crystal for the formation of the crystals. So, like for example, in this one, I just used a piece of this is cotton string actually, and I don't know if you can see here. It's difficult to see probably because of the focus, but on maybe I can focus here like this. That's right. The tip actually has very nicely, you can see the reflection there, very nicely formed facets. They're perfectly formed facets on that larger crystal on the tip there. And if this whole thing grows out, then, you know, it could have a Gans tube that it's formed around, or a nano-coated wire that it's formed around. I see lots of opportunities there. I've got this one, for example, this little guy set up, and it's just a wire that goes up and then back down around, and it's starting to build up at the bottom. What I'm hoping is I'll have the crystal grow all the way up this wire. Then I've got a double wire inside of a crystal, or not a double wire, but a bent wire. And then it's either a detector or possibly to put energy into it, and you could have coils around it to get energy back out, something like that. I'm not sure what I'm getting into yet here. I'm just playing with it at this point to see what some of the possibilities are. But I like the idea, I like the concept of growing a crystal around a core and having it attach itself. Like if this is nano coated already, this whatever, you know, wire stuff we have, and if it's properly nano coated, by proper I mean a consistent type of structure. For example, there's certain ways we can get pyramids, perfect little pyramids from our nano copper. Our nano structure will be little copper pyramids. You can have copper hairs, you can have copper tubes, you can have copper rods and copper, just general flakes and, you know, layering kind of thing. But we can actually specify what we want as that seed layer for growing the crystals. So I think if it was a perfect pyramid, we would probably get perfect pyramids out of the crystal. So if we can coordinate what this crystal, for example, this is the borax. So it's actually sodium tetraborate, it's called. And the borate boron crystals have a certain shape and they want to go a certain way. Well, if I can coordinate that with the way that the crystals are grown on my nano copper to make them both melt together, not melt together, build on each other, so they can work with each other that way. It makes sense to me that if you have a seed crystal of the copper, and you build it into a boron or other type of crystal, then it gives you a handle on it. You've got a hybrid, basically. You can work with it then, I think.
Rick,
So,
a couple of things come to mind while you're discussing this, and one is try a drip system, like a stalagmite formation with your borosilicate or with your boron, so that the drip of solution travels down the wire, deposits as it goes. The other thing I thought of when Doug brought up the geodes is I looked them up. They're inside of them. They're pretty much amethyst, which is a doped silicon oxide, or silicon dioxide, which is quartz.
right?
Filling up a geode with GANs would probably produce some very interesting results. But I was thinking that as the crystals are forming, the points are pointing in towards the center. So
That's
it
right.
may act as a concentrator, not
That's
as a
right.
radiator.
Right. So, yeah, it could very well concentrate and then radiate. That's the way that I would look at it. If you got all these points pointing at the center, all your crystal points sticking toward the center of this geode, like in a way, this will become a geode. I've got another one that I've got growing over there. That's what happens is it starts to grow up the sides of the container, so you can actually grow the crystals on the inside of the container. So I figure, well, that makes sense. What if I had a copper nano-coated sphere and put the crystal material on the inside to grow it? It would grow on the inside of the sphere. And then I was thinking, well, if I was rotating that sphere, the gravitational centrifugal forces would create gravity inside for those crystals, and they would grow, all of them would grow right toward the center of the...
That, Rick, is how thunder eggs are made. They come out of a volcano in liquid form, rotating, spinning in the air, and they are like little balls flying through the air, and then they land, and that's the result. Is the
Oh, is that right? And they cool off while they're rotating.
Yes, they cool off and they're in the earth around volcanoes. I live in a bloody volcano, so I know about it.
And do they take a long time to form inside the volcano first, or is it more or less?
No. I believe the whole process is the fact that they come out as a solid lump of liquid rock, spinning wildly through the forces of the volcano, and somehow during that spinning and flying through the air and cooling down and landing, they're already formed, and they cool, and I'm not really sure how it all finishes off, but it's all to do with spinning, and all the energies go inside, and all the little points, the pyramids are all pointing to the center. And if you cut one, you can see they're just the most amazing little mini something. We're just kids working with new stuff that we've never really thought about, but nature's been doing this for millions of years, and Mr. Keshe always says we're only actually replicating the natural forces and the natural processes of the universe.
Yeah.
So I think we're just now starting to realise that if, and all of the ingredients are natural if we want to. They can be roots, like's been mentioned, or trees, GANs inside plants, and also in the way nature works, forming rocks and forming crystals.
Yeah, when the magma comes shooting out of the volcano in the ball, whatever, we'll just call it a softball size or a grapefruit size. The outer shell freezes really fast, and it creates this hard shell. But the magma has a very high gas content, dissolved gases in it. So those gases get trapped inside. So there's actually not, if you look at the volume of that material, there's not enough material to make a solid volume. So as it freezes on the outside, all of the matter parts of it freeze to the outside shell, and it leaves this space of gas inside where the crystals grow into.
Mm.
The best geodes you'll find at volcanoes that spit into the ocean. When they hit the water, they freeze very, very fast, and you'll get the most striking crystal formations out of those ones.
Do they still grow for a period of time though? Once they
Oh,
hit the ocean?
they take a long time for that inside to
Okay.
form.
For the
Because
gases
all
to coalesce.
the silicon dioxide is suspended in the gases, and it slowly deposits and grows that crystal on the outside.
Yeah, it seems like time is important for some of these crystal growing processes, for sure.
Yeah. But I definitely now I want to go and get myself a nice little golf ball sized geode and drill a little hole in it and fill it full of Gans and see what the dogs do.
Thank you.
Yeah, exactly. You know, I mean,
So send me one, Doug.
people have been using crystals obviously for millennia. You know, we hear of stories of Atlantis, for example, crystals of Atlantis that were supposedly giving energy to the entire city and that kind of thing.
Yes.
So,
if I may, the crystal skulls that people talk about, that you know, what the hell's that all about?
right.
You know, they can't reproduce them the way the original crystal skulls, whoever made them or whoever constructed or created them.
Not to mention the tunnels and caves.
Not to mention the tunnels.
You see, some of these crystals are 20, 30 feet
Yeah.
long and huge like this around.
Yeah,
And
that's
these
cave in Arkansas.
These spelunkers are going through the cave, and it's about 120 degrees or 130, 40 degrees Fahrenheit in there, and they're plunking along trying to get through these sharp edge crystals. Boy, it's just amazing, amazing. I never thought of whole caves full of crystals like that, but obviously many parts of our planet down toward its core have that kind of thing going on.
Well, if you think about how the geode is made, and then you also think about the planet, if what we're told about the formation of this planet is correct, a whole bunch of crap came together, made this big molten ball, which froze in the vacuum of space. It's exactly the same process as a geode.
That's right. So it should all be crystal inside of the earth.
Yep.
We live in a crystal ball.
Gotta love it. Yeah. Love to go in there with a laser.
Interesting. Eh? So
I really think you're onto something, Rick, with the you know, building crystals on wires or hollow tubes, nano-coated tubes, and then try and you know, create crystal structure around the outside and inside, and then put GANs in, and you never know where this goes.
I actually, in my bowl here, I sprayed some GANs on things.
Yeah.
And threw a couple of chunks in of dry GANs to see if it would crystallize around it and so on. So I'm not clear on if there's any results from that or not, but definitely these crystals will have GANs as part of the structure. Yeah. When you think about it, you know, when something like this develops, this whole chunk here, and it's going to have GANs and the crystal structure. Now, the GANs in the crystal structure is like being suspended in a vacuum in a way. It's no longer freely moving around and just settling out like in its gravitational state in water. It'll settle to the bottom. Here, it's obligated to become part of the structure. And depending on where it gets frozen into that structure, it could, you know, isolate the GANs particles in a certain structure, a certain distance apart, where they have that, you know, similar to the plasma ball. If this was a GANs, then it has a field out here that goes bloop. You know, it's neutral, then bloop, it's got this big field out here. And so the distance of this GANs to the next GANs is critical, where that bloop is. That's where all the action's going to be. Not here, not here, not here, but here, right? So I think if we're able to trap the GANs, I don't like to use that word, but
And Rick, don't forget.
if we're able to position the GANs inside of a crystal structure in an exact way, we might have something.
Could you grow crystal around, say, a small balloon that you could deflate after the fact?
I don't know why not.
Piece of styrofoam bead that you could dissolve out, you know, something like
Right.
that to create a cavity inside.
Yeah, definitely that kind of thing can be done. I'll show you something else I did, which is, I'm just still working on this. It's very rough right now.
Ooh.
So this is a copper pipe cap, which I've nano coated. And I put 2 pennies inside, one Canadian, one American. They were both the pennies were ground down on one side to expose the zinc, because I use zinc copper pennies. Okay, so they're non-magnetic zinc copper, and Canadian pennies are both magnetic or non-magnetic, and pure copper or zinc and copper, or steel and copper. The ones that are magnetic are steel. The ones that are non-magnetic can either be copper or zinc. And if you get the later model ones, they're zinc. So if you hone down one surface and then nano coat the whole thing, you've got a zinc plate on one side and a copper nano coated plate on the other side of 1 penny. So I put 2 pennies together to make sort of a little battery and create some energy in there, put a bit of caustic in, and I put in 3 kinds of GANs, and then I put in the borax and kind of stuffed it all in there. And as soon as you put a little bit of moisture in with the borax, it starts to harden up. This is really hard. This surface here is just like rock hard right now, basically. And you can heat it at the same time, and it kind of bubbles up. And if you heat it while it's bubbling, it creates this popcorn kind of stuff. It's actually quite porous, more like perlite. And so right now, this crystal is actually embedded in there really good. It turns out that borax is used to help stick things together. And it's definitely stuck everything together in this one thing. Not sure what I'm going to do with it yet, but I've got a nano-coated surface that I can wrap coils around. And I've got the embedded GANs and crystal around the crystal. So I'm hoping to make contact with the crystal in literally and figuratively through this process. I'm hoping I didn't abuse the poor little thing. I kind of throwing everything at it here, and it's looking a little rough right now. But once I polish it up, I assure you, you'll feel a lot better.
So did you try to see if that would excite your ghost radar thing?
That could be the beginnings of a different type of health pen.
Yes, it could be. I mean, you could see this on the end of a wand, for example. You know, better be careful you don't poke your eye out with it, because it could be directional. But yeah, I don't know if I'd want to make it into a health pen necessarily. I would want to try to make it glow, though. I'd love to see some light come out at the end. That'd be cool.
That would be interesting.
Or heat. Heat would be fine. Light, heat, something.
Heat's definitely a priority on my end.
Pardon me?
Heat's definitely a priority on my end.
You can relate to that, can't you, John?
Oh, yeah.
I know you can. And I think that for Canadians, it's definitely a big priority. It's a big portion of where our energy bill goes, and a big portion of where we'd be pretty darn scared if the power went off in most parts of Canada, or if you lost your natural gas supply or something like that. In most
Yeah.
places where it's 30, 40 below, you'd be in bad shape really quick. Once your
Well,
house
I'm
heats
limited.
up like
I'm
that,
limited
it's
to.
pretty much toast after a couple of weeks.
Yeah, I'm limited to roughly 1100 watts here. I simply can't draw any more than about 1100 watts because all my electricity comes from a 200-foot extension cord.
Then you need 300 or 400-foot extension cords.
Yeah, well,
It's the
I only have
supply.
one circuit in the house that I can access, and
Right, yeah.
you know, right now when I got my heater running and I go to make coffee, I have to turn the heater on low or I blow the breaker.
Right, exactly. So having some sort of plasmatic heater would be quite advantageous to you, let's say.
Oh yes, that's why
Especially
when
if it
Mr.
only
Keshe brought
worked
it
at
up,
night.
when Mr. Keshe brought it up at the workshop, I think 2 weeks ago, I was like rapt attention, and then he stopped talking about it, and I was very disappointed. But I'll
Well,
get
I
there.
think we need to start talking about it in order to get him to talk about it. So
Yeah.
we need to make it more of a priority. I think I'd like to work with that for, you know, Canadians especially. I mean, it's something everybody in the world can use, except for a few places where it's too hot all the time, but they're pretty
Yeah.
seldom. It's even that they usually have cold periods. So, and then once you have heat, you can create cooling with heat too. It's just it's a matter of gradation and so on. So to create that source, that you know, everlasting heat source, that would be really something. So we can work toward that. We can talk about that and sort of come up with some ideas, perhaps.
Well, the thing that Mr. Keshe brought out was two. If I remember correctly, I could be all screwed up on this, but what I remember was two nano-coated plates with aluminum between them, and it's the interaction of the plasma through the aluminum that actually creates the matter condition of heat within the aluminum.
Aluminum, okay. Mm-hmm.
And getting the source of plasma, directable source of plasma, it seems to be a bit of a, you know, I don't understand that very well. It could be the coil reactors are totally sufficient, and now with the adding the crystal to it, because the crystal is going to be a much more powerful source of plasma than the little Gans ball. Whether I don't know. I still have so many questions. It's kind of a jumble in my head right now, and some of it's coming together, and some of it I don't think it ever will. I don't know. What are you trying to show, Rick?
Well,
It's just a white box.
Yeah.
You gonna draw us a picture?
Well, I was just thinking of when you're talking about that. So you were talking about, for example, say we had a nano-coated plate and another nano-coated plate.
Well, if you're doing something, it's not coming through.
Oh, okay. Maybe
Got
the screen
whiteboard.
The whiteboard's not sharing on my second screen for some reason.
Oh.
Let me try it again here. I'll try it a different way. This might work.
Well, the whiteboard came through. It was just a big white box, but there wasn't any drawings on it.
Oh, well, let me try it again here.
Playing with the new stuff. So I guess you're not working this evening. Otherwise, you're starting in 4 minutes.
No, there's nothing going on right now. How come I can't select this?
Okay.
Try this. So you don't see anything on that whiteboard, eh?
I get just a big white eye. It's about 1 inch wide and 10 inches long.
Okay, let me try it again here.
Oh, there we go. Okay. Now we got it.
So it can work. I'll try to bring my, I'll have to do things a little differently. Bring the live stream to the Zoom instead of the Zoom to the live stream, if you can understand that technical thing. Okay, so the idea was to just show two plates. And you mentioned, say we had an aluminum plate in between. Oops.
Well, it's pretty close to aluminum.
Just wrong size. Okay, something like that is sort of what you're talking about, right?
Yeah, and I would think probably a very high gradient GANs, one on top, one on the bottom. So a very, very powerful GANs and a very GANs, so that the plasma flow through that aluminum plate is very high.
Okay, well, my idea here would be if we can nano coat the plate with little pyramids like that and like this.
You need the dots.
Yeah, the dots are better, but I want to emphasize pyramids because you can create CUO pyramids like this, and another one here, say, another one over here.
These are four-sided or three-sided pyramids?
These ones are three-sided. I was going to check that out to see if they were, if it was possible to get four-sided ones with copper, or would you have to use a different technique or different surface? So this would be on a copper surface here, let's say. Okay, so it turns out when you have the right size nano pyramids, copper, on a copper nano surface, that what it does is it creates, it creates a whirling vortex, magnetic vortex over each of these pyramids.
Oh.
Just because of their shape. Because they resonate. They resonate about in the middle of the pyramid. You can, there's a file I need to find that I saw one time that showed the colors, the actual colors that resonate inside of these pyramids. And it resonates in another place, and then of course at the top. So it's got this structure inside that allows for a rotating magnetic field to form. What are they called? Polarons or something. It's polarons, or is it magnetrons? I forget now, but the point is that you create a more or less a bed of magnetic fields, and these fields don't just go away. They're always there rotating. So I figure if you have these rotating fields here, each of these tips and each of these tips, and as we know with a rotating magnetic field and aluminum, you will either rotate the aluminum or create eddy currents in it that will heat it up.
Yeah.
I say, create eddy currents in it that will heat it up. I say. And creating requiring no energy to do so, because these things are constantly replenishing themselves. As long as this distance was just right, it would seem like maybe some aluminum foil sandwiched between specially prepared nano-coated plates maybe would be a self-heating process, especially if it had vacuum in between here, so it wasn't trying to heat up well, the oxygen and other materials in there, just straight fields against the straight aluminum.
Have you guys heard of that ECAT project, ECAT product, ECAT thing?
Sure.
That's supposed to create a lot of heat, right?
Yeah, they use nickel plate and hydrogen, I think it is. And they get more energy out than what's put in.
Yeah.
One of the things that come up with the HHO guys is if you take your Brown's gas and you spray it through a catalytic converter, it will ignite. But right now we don't have a really efficient way of generating Brown's gas. We're still doing the brute force electrolysis method.
Yeah, but the output from the ECAD is heat. So if you're looking for a heat source, I don't know if you can get one working. That would be
for a cute little man.
That's the ECAT. That's a different. We're getting some interference here from something. Let's see. It's got some mics open or something.
That's just Doug and Roberts open. There we go.
Okay. I guess we're okay. Yeah, well, ECAT's a whole other ball game. It's a different, system and so on. So I want to play with plasma in the way we've been taught from Mr. Keshe, and the way I've learned from just picking up on the internet and other things like that. And this makes sense to me. This actually, as I draw it out, it makes a lot of sense. So that's something I'd like to play with. Maybe I can make a space blanket that's constantly warming.
The tetrahedral structure of the coating, do we have an idea of how that's produced? Is it a temperature or a vacuum or?
Yeah, I have to look into it. I've got that scientific paper tucked away somewhere. As I do there's several different techniques for creating different types of copper. You can have copper hairs, for example, a forest of hairs, or you could have copper tubes, similar to carbon nanotubes, a forest of tubes, or you can have cubes.
in case of these tetrahedral shapes, is that only on as a single layer nano coating? Because in our case we have, what is it, 30,000, 40,000 layers of
Right,
coatings. Would you still have the tetrahedral shapes on that?
What happens is the layers build up in the tetrahedrals, essentially. So this builds from the seed. If you have the right, like I believe in this experiment, they started with super pure copper, and they prepared the surface by cleaning it and sanding it in multiple sandpapers down to 6,000 grade sandpaper. And then you clean it with 3 different methods of cleaning. With you use alcohol and some other solvent, and then you blow it off with nitrogen, I believe it is. And that leaves the surface ready for the process. It has to be super clean in order to get the right seed structure for these pyramids. Otherwise, you will get a mishmash of just general layering and sort of overlaps and flakes, and you could have some hairs and different things, with a haphazard process. But if all the conditions are controlled with your atmosphere your temperature, your vacuum condition, and
your intentions.
pH is very important. And of course, yes, your intentions, which is probably the most important.
I think so.
Pulls it all together. But there's lots of other factors besides intentions. I mean, you can have the best intentions, but if your conditions aren't set up, then it's just probably not gonna happen.
Yeah.
Although with strong intentions, might be able to overcome any conditions. I don't know about that.
You might have the best intentions, but you can't split wood with a toothbrush.
Well, I'll give you an example of a piece of straw in a severe cyclone. A piece of straw went right through a tree, small tree.
Yep. Yeah,
Thank
my
you for
parents lived
the
in Wisconsin,
velocity.
and they had straws in trees, and
Is that right? Yeah.
yeah.
Hard to believe, but
Well, you get it going fast enough, and the tree turns into putty. I mean,
yeah. So that's why I'm thinking even a toothbrush at close to the speed of light might be a lightsaber. Lightsaber in the wrong hands. Some kid gets whipping it back and forth fast enough, suddenly it becomes a lightsaber. Yeah, so interesting ideas there. I think I'd like to learn a lot more about creating specific types of nanomaterials as a base for our constructions. Something that would, logically work better. In certain circumstances, you might want hairs or rods or just the 30,000 layers as to conduct. To conduct might be better off having superconduction happening between the layers. This is more on top of the layer in this case, and it does become a quasi superconducting situation here because of the moving along of electrons or holes, depending, same thing basically, in different directions. You can move holes, or you can move, for example, just moving one of these rotating magnetic fields so it's no longer there, and then move it to the next spot so it's no longer there, and so on. We'll move charge. You can move charge by creating holes, essentially.
Yeah.
And that's another kind of nano coating. If you have a nano coating with lots of holes in it, then it can create a structure that's repels water, for example, or it can create a way for charge to move between the holes. Instead of having an electron move, you actually have the holes move. Makes more sense in a way.
Yeah, it's very similar to or my thinking anyway, they're very similar to a Helmholtz resonator, but for extremely high frequencies. It would absorb in the terahertz, and what would a quadrillion be in math speak?
Mm-hmm.
When your hole is 20 angstroms across, the wavelength that's going to get trapped in that hole is going to be very, very short.
Yeah.
Are you guys clear on plasma? What it is?
I don't think anybody's clear on plasma just yet.
To me, plasma would be what's created in between here, in between these sandwiches, due to the rotating magnetic fields and any stuff in there or anything inside of there is going to become plasmatic just due to the gradient.
Yeah,
Potential.
by definition, it's an interaction of mag-grav fields, which is a pretty broad definition.
Well, according to Mr. Keshe's book, though, he's saying plasma is the neutron. And when you create the proton and electron separating out of neutron, sort of a big chunk breaking off and a little small chunk, the big chunk becoming proton and the little one electron, is what we're calling plasma, and the effects associated. Is it just sort of bunch
Well,
of neutrons?
Robert, look at it not from a particle standpoint, but a field standpoint. Look at the neutron as a undifferentiated field, a ball of field, or an undifferentiated Coulomb barrier. And when you differentiate it, when you give it a value, for lack of a better term, then you would generate either the field of a proton or the field of an electron. Does that clarify it in any way for you?
Well, the way I understood is when the big chunk, sort of the whole chunk separates into a big chunk and a small chunk, they were still the same, sort of the same field, right? Except one now was smaller, one was bigger, and with a given ratio between them. So you still have the same fields. Now you have a little bit less of it in the proton, and the rest of it becomes your electron. But if essentially the composition of the field is still the same as what you started from.
Yeah, when you split them apart, you are adding a differentiation to that field, because there is a difference between the two. Now, whether the difference is just field strength or if there's other elements involved in that, we're not really well, I'm not really too sure yet. But the way I view it is the neutron is the undifferentiated field. It's the core value of everything. And then when you split that, you're creating a gradient within that value, whatever that value happens to be, whether it's field strength or Coulomb barrier size, or I don't even know if we have the word to describe what's going on just yet. But you are creating a differentiation within that field when you have the two particles, or the proton and electron. But I really push myself away from viewing it as matter, as a particle. I view it as just the field, or the barrier, the balance point of this little ball of energy field.
So then what you're saying is that ball of energy field is the minimum plasma unit, as in comparison to the matter world, where let's say we say I don't know what it is now, the electron is the smallest matter particle in the plasma world. Would that be the smallest unit of field?
Well, if I understood what Moran was talking about, it's not about size, it's about strength. And he also mentioned that when we get down to the core plasma level, we're going to find there's another level below that.
That's right. So
I
even
don't
the electron.
the core level.
Go ahead. Sorry.
Well, I don't think the neutron is the core level. It's the core for us at this time, because that's basically as far as our thinking can go right now. But he did allude to there's another layer below that. There's a simpler form below that. And we're not anywhere even close to getting there yet, I don't think.
Well, I mean, if that field, yeah, let's say you don't want to think of it as a particle, matter particle, but it in the matter part of the universe, it acts, it is the neutron, or it behave, or it shows up as what we call a neutron, and it has certain properties as a particle neutron. Can we think in terms of neutrons and sort of in the background imagine these fields, but for our better understanding based on what we have learned to think as, we think of it as neutron particles, but give it a plasmatic,
I think what you're getting at, maybe I'm wrong here, but I think what you're getting at is, yes, the neutron is the base system that everything is created from.
Right. So is in what we call plasma, even though those are fields, if we think of there being neutrons, let's say going from copper into copper oxide, the nano layers, are we converting some of the proton electrons into neutrons, and thereby the atomic number is reduced, because in the counting of the, I guess, atomic mass, there's a 20-30% reduction when we're going to nano-coded form of it.
There's a lot of physicists, I think Nassim Haramein touched on this, that their models suggest that it's not a static system. Say a hydrogen atom isn't just a hydrogen atom. It's popping in and out of space and dimension and time and everything. It's all over the place. So we can't. I don't think we can view it as a static system like that. And I think that's also what Mr. Keshe is alluding to, is that when we deal, or when we think of it as an interaction of fields, we naturally view it as a very, very dynamic system, and it's constantly in flux. It's just when it's in a balanced condition, that flux is at a certain rate or a certain frequency or certain field strength, however you want to view it, that we would perceive it as a plate of copper. But if you got right down and look right into the energy of it, that energy is in constant motion. It's in constant flux. It's always changing from one type of matter to another.
Yep.
Because we're perceiving the macro, and we're trying to wrap a macro perception around the subatomic, and that's, you really have to stretch your imagination and your visualization a lot to be able to see this. I'm having trouble with it, but I can kind of see it a little bit.
Well, one thing that helped me recently, that a little factoid that I ran into, just draw your regular water, for example, with you've got your hydrogen and you've got your other hydrogen, and they're supposedly attached to an oxygen at a certain angle, and so on and so forth. So you would think that would be a relatively stable compound or stable combination of elements, because water doesn't just suddenly blow up on us or catch on fire or something. We're pretty much
unless you're in
settled in with
Texas.
water. Water's good. It's easy to control, easy to figure out. But I ran into a little factoid recently that I was astounded with, which is in any regular water where you've got, normally you're going to have, a bunch of these all sort of sitting around together, various H2Os. And you think they would just be completely stable. But what happens is, in the middle of all this, is let me see.
Yeah, the cluster.
Let's see here. Well, what can happen is there's fields inside the water. Okay, and these fields are somewhat random. And what happens with fields and that kind of thing is sometimes you'll get fields that attenuate. So you get two of these fields are on top of each other and giving a really big peak all of a sudden. These are just the energy fields within the water systems, right? So all of a sudden you have these peaks where if that water molecule is at that peak, what can happen is a spontaneous ionization of the water molecule.
Yeah.
The hydrogen becomes well, actually it becomes a hybrid H3O plus molecule, but essentially the oxygen and hydrogen separate. It's a strong bond. It takes a lot to break down water normally. The HHO guys know about that. But it spontaneously happens about once every 20 or to 24 hours to each and every water molecule. And I thought, that's great. I love it. So this water molecule sits there for 20 hours and all of a sudden, ka-chunk, it splits its bonds because it happens to be in one of these peak wave areas. But within a picosecond, it instantly reattaches its bonds as if nothing happened. Nope, that didn't happen. You didn't see that. That wasn't me. Nope, not me. Don't see me cracking my bonds. No way. Well, it does. They've actually, now that they have ways of measuring down to the picosecond, which they didn't have a few years ago, they've actually seen this and measured this phenomenon taking place and measured it as being once every, I forget if it was 20 or 24 hours. It's a very exact time, not just random, but I mean, it's random, but it's exact in terms of as certain number of molecules will have a certain number of these spontaneous ionizations occur. I thought, well, geez, then that same thing must happen in every substance. Essentially,
Yeah.
we'll get spontaneous ionizations occur. I thought, wow, well, what if we could train that or build that up or work with that in some way to give us the ionization we need to create our plasma. It's essentially what plasmas are, or at least as far as science measures plasmas, there's always some sort of ionization occurring. And definitely on the nano level, that's part of what goes on with their nano coating process and with using sodium hydroxide, the caustic right off the bat. That's a process that just rips the hydrogens right off and creates all kinds of plasma process.
It makes me wonder if the nano coating is one way to order that interference pattern.
Yes, I do believe so. I believe with the correct nano coating, it would automatically break the HHO bond just by passing water over the substance.
Very cool.
And probably it would be a pyramid type structure that would do that as well. Because that's where you get those peak energy concentrations. And with the right spacing, of course, for, you know, your bond breaking, whatever that is. So interesting anyway.
Yeah. Well, any combination of sinusoidal energy fields interacting with one another is going to create high energy and low energy areas within
That's right. And there's not a single square cubic centimeter of anywhere in the universe that doesn't have fields, waves.
Yeah.
Well, then when we say everything is fields, are we saying everything is a wave pattern?
Yeah, essentially all phenomena is illusion. It's all illusion, and it's all just waves and wave patterns, and it's all just rotating magnetic fields. And it comes right down to it. Everything that we think we are, everything that all the physicality, everything you see, touch, taste, feel, and so on is just simply wave patterns. Nothing.
Well, what is a wave? What is a field then?
Well, it's the fluctuating field strength of the plasma. That's where we're basically boiling this down to. But you got to look at it in you got to look at the minutest aspect of this in the largest scale possible, so that you can see that it's interactions from every direction all at once, and it's always happening, and every single cubic angstrom, whatever, I don't even know, I don't know a smaller distance. I guess a Planck length would be the shortest one that we know of. But if you had a cubic Planck length of space, according to our math, that would be the smallest available interaction space that you could have. So that would be one single waveform of this plasma energy, if that math holds true. So if you could look at a cubic Planck length of space, you would see one single waveform interacting with all of the single waveforms traveling from all different directions, and you could see the peaks and valleys of the interference, the heterodyne that would be created by the interaction of all these fields. But you got to remember, you've got an infinite number of fields all interacting at once. So the heterodyne is going to be all over the map. It's not going to be one single frequency or one single field strength. It's going to be everything all at once, which is really hard to wrap my mind around. And I think I just burned out a brain cell.
Yes, but on the other hand, some of them are existing for a certain, it's what we consider a time period. Like, for example, the Earth as a entity. It's we could say it's just the crossing of fields, or the interaction of fields. The what's left after the fields are, you know, it's the remainder. What's left after the fields have interacted. But it gets a little dicey at times because we're so used to seeing things in the matter level and physicality. And yes, there really are particles. They just got my eye, and I have to go clean my eye out because I can't see. I got particles in my eye. They're not magnetic fields, they're friggin' particles, and they hurt. You know, sand, get some sand in your eye and tell me it's just magnetic fields. Don't worry about it.
Yeah. And this, you know, again, that kind of brings up the idea that if you look at the solar system, it's an atom, and it could be an atom in somebody's coffee cup somewhere, you know. So
And
size
there's
doesn't matter, time doesn't matter.
If you add up all the if you take out all the space between the atoms and just include the atoms and no space, I think something like our whole solar system fit in a cubic centimeter, something like that.
Yeah, it's I think the latest numbers is 1/1 millionth of your volume is actually stuff. No, 1/1 millionth of 1%. Sorry, so it's 1/100 millionth of volume is actually stuff.
Right.
The rest is just fields.
Stuff is in being matter.
Well, yeah, in
Or
conventional physics speak, they're still thinking in the matter state. So they look at an atom and they look at the ratio between the interactive barrier of that atom and what they believe to be matter within it. And it's you know, there's only 99.99999% space.
and that would be plasma.
Well, yeah, that would be the
Fields.
field, that would be the field interactions. And you know what we're perceiving as stuff is simply the Coulomb barrier of an energetic reaction or energetic interaction.
Which is
So
plasma on another level. So it all depends
exactly.
on what level we're speaking of. The sun, the plasma of the sun is grand and large and big. But if you look at the plasma of the hydrogen atom that's in the sun, if you just look at each individual atom, then that would be a relatively smaller plasma, but still another form of plasma.
Yeah, layers upon layers upon layers of field interactions, each one producing its own barrier that we perceive in a different way.
Yeah.
But Planck's constant would be Planck's length would be the minimum for the field or just for the matter state?
Oh, I only use that as an example, and that's the Planck length is the radius of a proton, or radius of a photon, which they assume to be the smallest thing there is. Now, we know we live in an infinite universe, and we can go infinitely large or infinitely small. So a photon is certainly not the smallest thing there is. But when you're dealing in the matter state, that's the smallest thing they've found. So that's what they're basing their math on.
And you mentioned
that's the seed sort of for the matter state.
Well,
seed size sort of.
You could look at it like that. I suppose you could look at it like that. The fundamental smallest field interaction that we can perceive as something. So yeah, I suppose you could look at it as a seed.
Yeah, I think that's important. This idea of a seeding our experiments, you might say. What are we starting out? What are we starting with as a root? What is that? It really gets down to the core intention, and also to very basic geometry in a way, because the geometry it's all about shape and size with nano-materials. It's that sweet zone of where size matters and shape matters. And if you're bigger or smaller than nano, then it doesn't matter in the same way at all. So definitely a lot to be looked at in that realm. That's why nano is $1 trillion a year industry now.
Yeah, unfortunately, our language is woefully inadequate to describe what we're seeing in our heads.
Yeah, and even the scientists in their experiments have woefully inadequate language too to figure out what they're doing and how they're doing it, and and along comes somebody from some third world country with a facile method to do exactly what the scientists were doing with their very difficult, complicated methods. And that blows them right out of the water. It's just like, you know, you can imagine you just spent 10 million bucks for your new super duper lab with all its sophisticated equipment and so on. And some kid from India comes along and creates the same nanomaterials in the one pot facile method using some kind of jam and you know, some leaves from some plant or something. And that's literally true. These kinds of things are being done. They call it the facile one pot process for creating such and such a nanomaterial structure. And this is the latest and greatest, like Mr. Keshe has been teaching us. It's a simple method. It's you just put your stuff in and you throw in your caustic in some hot water and bingo, you've created this amazing nano coating on a copper surface. It couldn't be simpler in many ways. What we create, we're not sure yet because we haven't done all the tests on it to take all the pictures and do all the sophisticated tests and so on. It has to be done for many different samples because everyone has a slightly different technique that's going to produce a slightly different material. So I think there's a lot of room for fun and opportunity in that. Looking forward to when the iPhone app comes out, the nano structure magnifier for iPhone, which should probably be pretty shortly, I believe. They'll have some sort of adapter that will clip on and you'll be able to see the actual nano coating on anything, as well as bacterial bugs and all kinds of crazy things.
Yeah, every 10-year-old kid will have an electron microscope in their pocket.
Yep, kids will be pulling them out to see what kind of microbes they have in each other and so on. Treating microbes like baseball cards. Look at this one. Look at this one. Oh yeah, that's cool. Oh, I'll trade you for this one I have.
Yeah, don't deal with Billy. His microbes make your nose run.
Yeah, that's right. Well, it's easy to see when we magnify them. They've got 8 arms like an octopus and they stick onto your nasal passages, obviously. That's the kids of the future will have that all. It would be nothing to them to be doing this kind of thing. They'll be creating new nanostructures in probably grade 1 or 2 in the next few years. I mean, brand new nanostructures that no one's even thought of before, just because some kid was playing around on their 3D create a nanostructure program, you know. Same as the coils are made. The same thing can be done basically with kids these days. Like Robert's coils are very cool, look really neat. And imagine if a kid could take that and suddenly start creating actual structures with it and putting on different nano coatings and trying it and see what happens to it and so on, just through a plug and play program that you can stretch and pull and plug in things, and you know, all of a sudden, look daddy, look mommy, look what I created.
Well, I'm pretty sure we'll wind up with computer models, but we don't have any parameters right now. So
well, that's the problem.
It's totally intuitive at this point.
Here's 10 billion products. What exactly would you, or 10 billion coding, what exactly would you like to do with your coding? And you can custom make it, but you have to decide what you want to do with it. And that's the hardest part.
Yeah.
That's the bizarre part about it all, I think. It's if we could just focus on what exactly we wanted to do, probably anticipate what kind of structure it should look like and create that structure with all the ways that can be done nowadays and actually do whatever it is we want to do.
Mushrooms, lots of mushrooms.
We already have so many choices in products now, and if it becomes now a choice of what you want to do with your product, the choices are going to be even more. It's going to be even harder to pick something, and people will be spending a lot of time researching before they
Well, that's the
buy
thing.
something.
By the time you thought of it, someone else has already done it.
Yeah.
That's one of the problems of our society now with trying to invent things is if you take too long, then it's already been done and someone's produced it and it's available at your door from Amazon or whatever.
Yeah,
In
products will be
15-minute delivery as they're going to have in the next year or two from any to any place in 15 minutes by drone.
people would be the best designers would be those who design intuitively rather than thinking logically and trying to calculate every aspect of the design. People who intuitively feel like what the design should be like, they could bring the product to market faster.
Well, we already
Very
do that
well.
to some extent.
Yeah, that's what you guys do.
When you're dealing with the ergonomics of a device, it's pretty much intuitive. We just need to expand that to actually function, not just form.
Mm-hmm. Right,
Yeah.
and in the future, the function and form will,
Form and function, yeah.
if it looks like it works, it will, because that's just the way our perceptions will go.
So if it looks like a duck, it's going to quack, I suppose. Yeah.
Well, that's the way Nikola Tesla did it. He visualized his invention. Every time he had a new invention, he would visualize it in his mind first before he made it, and he'd mock it up and have it all running and with bearings and seals and everything else. And sometimes he would run it in his mind for months and find out what parts would wear out over that time and fix them in his mind. And then when he came to actually build the device or have it built for him, he said it won't take time.
Rick, last time you said that Tesla said that his turbine was his greatest invention rather than all his electrical stuff.
Mm-hmm.
Do you know why?
Well, first of all, he said that he believed and said that his turbine would scrap all of the heat engines of the world. And he said that to his friend Scott, somebody, and he turned to Tesla and said, that will make quite a pile of scrap, and left the room because it freaked him out to think that this turbine would scrap all of the heat engines of the world, all of the piston type engines, all the other types of turbines, any engine essentially that ran, mechanically. And Tesla really believed that, and he made a number of prototypes that approached being, quite good, but they had some problems with materials back then in the early 1900s, and trying to create high RPM turbines are running 30, 40,000 RPM. The disc would stretch and warp and that kind of thing. So he had problems with it. But what I believe is what he wanted to create would be essentially, if you look at the Tesla turbine, it's got an injector nozzle, and it's got fluid that goes inside of it, and it's just got discs inside the turbine, square discs. It's hard to make a mouse go round. So these discs end with a hole in the center, and so your fluid comes in and rotates around and rotates over the discs and toward the center, and eventually exits out the center of this device. So what happens at very high speeds with this is certain special processes take place. And I believe what happens is essentially a plasmatic process. We end up with a colors here. Essentially with a plasma in here in this zone between the disk and the case of the unit. Now, Tesla ran his units on steam primarily, but also the Tesla turbine's able to burn fuels directly. It's the only type of turbine that can burn, for example, straw. It can burn straw directly into the intake and burn it and make power out of it, and the results, the carbon comes out through the exhaust. And it won't hurt the turbine. It builds up a little bit of carbon, but they did testings a few years ago, and they used straw and I think oats work as well. So you grind them up, you create this powder, and you can run it directly in the turbine. Well, he used other types of fuels, including even gasoline was used as well. And it was the Tesla turbine was poised to be used in the Model T. And Ford approached Tesla, and Tesla was all excited that Ford wanted to come to his lab and check it out and so on. And Ford and his entourage came to the lab, but only to try to talk Nikola Tesla into joining their industrial group, because they weren't interested in the Tesla turbine. They knew it was going to be a good engine. They didn't want it. They had the internal combustion engine totally sewn up, basically, at that point. Between that and the turbines, the regular type turbines, Parkins turbines, so on, there was, Edison also got involved in that. So Tesla's design got sort of left behind in a way. But what happens in this one area, I was trying to get back to this idea of creating a plasma in this device. And why I say a plasma is because of the shear forces that are involved in this situation. We've got these layering. You've got layers of gases inside of a turbine, for example. It can also be liquids, but let's look at the example of gases. So you have, with centrifugal gases, as we know, and the reactors that are rotating, you causes a centrifugal force, and so your denser materials are always at the outer edge here, and it goes lighter and lighter toward the middle. So you have a gradient. It turns out the gradient at this point in a high performing turbine, especially one that could be made with modern materials, it's a very, very high gradient. So any chunk that's caught in this gradient, you might have, for example, 1,000 miles an hour at this outer edge, and maybe 500 here and 200 here and 100 here. Well, between that 1,000 and 500, there's an extreme gradient, and even more between the 800 and 1,000, let's say. It'll be a thin line. So what happens is any chunk or particle, anything that's got any substance to it, gets in this, it starts rotating and gets completely broken up, chopped up, reduced to its prime constituents inside this rotating shear environment. So essentially, you break down the particles to their basic components. So if you had a hydrocarbon, for example, maybe I don't know.
Yeah, they pulverize rocks with similar equipment.
Yes, right, exactly. You can use a vortex. I've seen a vortex, a simple vortex.
Yeah.
Guy take an aluminum can and put it into this vortex and hold his hand out underneath, and you get the dust from the aluminum can. Okay, there's a YouTube movie of that actually. Well, that's the similar kind of forces that occur inside of a Tesla turbine. Once you have these breakdown particles, you basically are broken them down to their ionic components, charged particles, and you have a charged plasma environment in there. And so if you have a charged plasma, then you have a gradient across this disk. What essentially you can do is precipitate out elements on this disk or in the environment of this disk as they cool down and slow down going toward the center of this contraption. So you have a way of disintegrating, first of all, gross fuels. So that means, for example, if you were to run diesel exhaust or diesel fuel in this, it would break down the components so much in this that what comes out through here is pollution free. Basically into its, it might have carbon monoxide or carbon dioxide is the most likely basic component that will come out. And of course, water. And that's your carbon, oxygen, hydrogen combinations. They break down to their most basic components, which are carbon dioxide and water, usually. And so what happens is you don't get the black smoke, you don't get the particulates, which are the biggest health issue of the decade, according to the United Nations years ago. You don't get the chunks, you don't get the carbon nanotubes, you don't get the carbon buckyballs and all the other crap that you get in a regular diesel exhaust motor. You get broken down gases that are no longer particles. So that to me is one of the major things about a Tesla, the potential of a Tesla turbine. I think Tesla saw that potential, because what happens when this turns into a plasma, the whole thing becomes over unity as well. Normally a Tesla turbine can run 97, even up to 99% efficient when it doesn't have much of a load on it. When you put a load on it, the efficiency can go down to more like 10 or 15% for a heavy load. But the light load, you can get very high efficiencies. And Tesla said that sometimes the efficiency goes over 100%, even on his relatively archaic turbines, when essentially they start running by themselves.
Well, that
air.
The turbine, the way you drew it, at the perimeter having the plasma field, as it goes towards the center, like Mr. Keshe was describing, they slow down and then you start forming your different materials, different elements, as it goes sort of towards the earth. As he was explaining, you start creating, sort of precipitating out your different elements, carbons, oxygens, and nitrogens. So it looks like a similar process going from the plasma towards the center.
And the great thing about the Tesla turbine is it's actually reversible and it can become a pump. So the exact same patent for the turbine, it can be used for a pump without any changes to the initial thing. So you have a shaft here, you have a motor that rotates the shaft, and this disc rotates. It throws the fluids out, and in that case, it goes out through this inlet. And
Yeah.
in that case, you create enormous pressures on the outside here, and you can create a vacuum on the inside here. So again, you have quite a gradient from the inner to the outer, and that can be taken advantage of. I know that can be a really advantageous thing. For example, in I could run into so many ideas with this, but in thin film technology, where they have a rotating disc, and the disc rotates, and you drop some drops of fluid on this disc, and it forms a thin film as it flows out on the disc when it's rotating, right?
Yeah.
So this thin film, we're finding out, has amazing, miraculous properties and so on. That's what they use for electronics now and that kind of thing. So that same thin film type technology could be used inside a Tesla turbine, where you have very special conditions, and depending on substances that you use, besides water as a fluid or as a gas, then you can compress the gases and have them in different layers. You could have tubes going in that feed in and then feed out from different points in the turbine, where you have your compression and wavelengths, and all are just exactly right for creating certain substances, or where you can inject certain substances and they get converted, and this kind of thing. So I see the Tesla turbine as a truly multi-dimensional, multi-purpose device, and I think it's just a grand, wonderful thing. I experimented with it.
Yeah. I think the reason it hasn't been so successful, or it hasn't become prominent, is because it's not being used the correct way. I think Tesla didn't intend it to be a type of a motive thing. Rather, I think he intended it.
What he built it for? According to what I've read, the reason he built his turbine was for his what do you call it? It's a flying machine. And most people have not heard about Tesla's flying machine. It was supposed to use 4 of his inventions. It's hard to draw on this thing. So his flying machine used 4 of his inventions. One of them was the Tesla turbine. He invented a dual 200 horsepower, that's 400 horsepower altogether, Tesla turbine on his 50th birthday that was destined to be used in his flying machine, because it was the lightest weight, most powerful motor available. And his flying machine had no wings, and no airbag. So it was not a balloon, and no wings, and it was electric. It was electric, and furthermore, the reason for the turbine was not to rotate blades or to rotate a propeller or anything like that. The turbine was just to rotate two counter-rotating turbines were to rotate the electrical generators, 200 horsepower electrical generators. for his electrical flying machine. Okay, so now you got 400 horsepower. That's like roughly equivalent to 400 kilowatts of energy. Um, to activate his fields that he was working with his flying machine, the counter-rotating fields.
Yeah, but I think he even though he didn't talk about it, I think he was pretty well aware of the what we call plasmatic fields and gravitational and magnetic fields. He didn't call them as such, but I think he was well aware of it, and he was probably designing UFO type of flying apparatus with the plasma effects that he got in his
That's right.
turbine.
You got to realize that Tesla was already playing with evacuated tubes of gases that had either no electrodes or single electrodes and so on. He was not into the incandescent lamps of Edison. In fact, Tesla said the incandescent lamps were bad for you. That they would cause you to go bald, he said. So he worked with more like fluorescent lamps. And,
Yeah, gas, a glowing gas.
Situations, and he had all kinds of bulbs he worked with that were essentially a plasma. In fact, he was the inventor of the plasma ball. He had a big plasma ball he stuck in the middle of the room, and when people came in, it would influence the ball. The tendrils would point toward people that would come into the room, or would be influenced when they did things and so on. A super sensitive plasma ball. I mean, we can tell by plasma balls are influenced by people, obviously, and I've shown how my evacuated vacuum chamber, when it's got high voltage in it, responds to people and creates different sounds and so on, according to how close you get to it, that kind of thing. Definitely Tesla was playing with plasma. And he had his gravitational theory, he said, already worked out by the late 1800s. The reason we don't see the results is because he was basically shut down by governments and so on. He was scared that the governments would misuse his invention and use it for war, which of course is the first thing they wanted to do with all this stuff. And that was around the time World War I was breaking out then, and he saw the results of that and the results of man starting to use the airplanes against each other and this kind of thing. And furthermore into the 1930s and 40s, and he saw no opportunity to present his greatest, what was really his greatest invention, his flying machine, because there was, no one to sell it to that had any enough ethics to actually run the thing. So that may be still the case today. I'm not quite clear on whether we're going to be able to handle a plasma flying machine or not as a culture. So the first thing we're going to do with it is turn it into a drone. Might be okay if it's just Amazon, but if it's used to drop bombs instead of gifts, maybe it's not so good.
We gotta put a backdoor switch on all our
There you go.
so we can go back in and hack it.
Well, I think, I've had a flash about all that, and it might be that the drones of the future, like Amazon drones, they've got a whole fleet ready to come out and serve the public next year. They'll have, 15 minute delivery from their warehouses, which are all located within a major metropolitan areas. So anywhere in this within a city, you'll have 15-minute delivery of anything you can order on Amazon, essentially. And these drones will be special at that point because they will be able to identify who's around by face recognition. They'll be able to tell whether if someone is being harassed or threatened or other emotional traumas. They'll be able to notify the authorities if necessary, and basically there'll be an eye in the sky, and people will want them in order to keep themselves safe. They'll want to have make sure the neighborhood's safe and no ISIS, terrorists are coming in to bomb them or hurt them or whatever. And this will be one of the jobs, I think, of the drones of the future will be to help maintain the peace.
I don't know. Or maybe they could be Big Brother's little, spies and snitches.
I was thinking target practice myself.
But the thing is, are the corporations Big Brother? And I think they have their own agenda. And one of their agendas is they want to keep on the good side of the public as much as possible and sell more stuff. They don't want to be caught spying and thought of as being bad guys that are, with people's rights and so on. We all should have the right to buy whatever we want, and it should be free. And it may be in the future. Maybe you'll get stuff just delivered to you free, just because it's so cheap to make it. If you use it and use our brand name, we'll allow you to have it for free, just because, that's the way the future might be going. And so
We'll have brand wars.
That's right.
In the future.
Brand wars, and instead of having real wars with real guns, we'll have play wars, and it'll be whatever corporation can sell the most stuff wins, or something like that. It's essentially the way it goes now, anyway. I don't know. Anyway, maybe we should sort of wrap things up here. It's gone a couple hours more than I expected.
Yep, good session. Thank you.
Yeah, thank you for all the inspiration, you guys, and thanks for those pictures, or rather, not, you shouldn't call them pictures at all. The files on 3D files.
I tried to, my intention was to have it in a e-drawings format, so anybody can open it and rotate it, zoom in, but the file size is about 10 megabytes. And I noticed that on like Android phones, if you want to download the e-drawings app, it's like $1.99 or something. It wasn't free. So I made a 3D PDF file, but the file size is like 20 megabytes. So maybe I can upload it to, somewhere.
A drive.
People can download from there. Does Keshe's, there's a site that there is one for the groups. Does it have a box to upload to?
There's you could go to the blueprint teachings. Let me see let me get the exact website here.
I don't think there's file capability yet, is there, Rick?
Well, what you can do is just put in as if it was a personal contribution to the website, and it'll get uploaded there as just a file or some sort of picture. And then we could also have it included in the actual blueprint file PDF thingy as well, I think.
Yeah, I'd like to put it with that the drawing, the 2D drawing, because it uses the same color scheme. It can go with that, and people
Yeah,
can have a 3D view of it.
that makes sense, yes. Okay, so okay, there's the blueprint.
Yeah, sorry we didn't get to you, Salama. Mr. Keshe got talking and we all kind of got enraptured.
Where's the blueprint? So, okay,
Hello,
so
hello, Ring.
hello.
Yeah, sorry. It's something in my mind, that I need to ask.
All right.
Is it okay?
Yeah, go ahead.
Yeah, with the stacker, and it's like a tower, I was expecting something like a spark gap, which we were told that uh, with nano coating, we have a spark gap, but it doesn't exist anymore. I don't know where it went. It was downplay or it's not in the right play.
Spark gap.
You remember?
I'm not clear on this. Anybody remember spark gap?
Yeah,
The
when
only
we do coating, when we do nano coating, all the layers supposed to be spark gaps. Where Tesla has only one spark gap, but nano coating supposed to have thousand and thousand of spark gaps. You remember
it
that,
may have
that part?
been a, it may have just been a way for him to describe how the layers interact rather than an actual occurrence.
Well, I
The only
do.
thing I remember talking about sparks is if it sparks, turn it off and wait for it to dry. That's the only thing I remember
Yeah.
about sparks.
When we asked him about spark gap, he told us this nano coating has thousand and thousand of spark gap because of the layering and because of the subatomic.
Right. Yep.
So
that makes sense to me. Absolutely.
so I was expecting something of a spark gap inside the stacker. It's like a tower also, right? But it doesn't
Well,
exist.
it does in the nano layers. If you were to look at the let's say no, it's not good, but anyway, say this is their base material here, and these are your nano layers on top. Then you could very well get sparking between each layer, essentially
Correct.
sparking about what we call it's more of a plasma. It's a ionized gases or ionized field. It could be anywhere in between because these nano layers are so close together that even a voltage difference of less than a volt,
Yeah.
will still,
So
since it's such a low gap and it's a vacuum in between, and we know that 10,000 volts it's 1 centimeter is roughly 10,000 volts. So if you were to go, 1 nanometer would be 1 nano of 10,000 volts. So if there was a nanometer between each layer, then it would take
correct.
for a nano to jump the gap or create the plasma. So essentially, we could have many spark gaps or lightning bolts or plasmatic interactions among the layers on top of the nano-coated coils, for example.
So if with Tesla he double up, say with his one spark gap. Correct?
Say that again.
With Tesla, he double up with his one spark gap.
Doubled up?
Yeah, he doubled up when he first jumped the spark gap, it double up.
2 spark
And
gaps, is it?
yeah, when he goes into the tower, tower that he does, it doubles up and doubles up. I was expecting something like that when I saw the stacker, you know.
Well, everything's on the nano level. It could be that a spark gap. I did have a drawing I looked at the other day. It had a coil, and it was actually the old Model T ignition system. So you have a coil, and you have a little actuator at the end. It has a spark on it. It's a vibrator. It vibrates, creates a spark, and every time the spark gap opens, it collapses the magnetic field and makes spark.
Yes, correct.
The gap.
So when he did the 70 workshop, he showed us the 3 coils that is after LX, and he said it was a tremendous power on the 70 workshop.
I believe that, and I think it's all in the nano level though. And we have to find a way to access that. I think these little sparks that I show here are enough to set up the same effect as this spark gap, which is a collapse of the magnetic field, which sends off a pulse.
Yes, correct. So I was expecting something like that in the stacker, you know.
Well, why don't you build one in?
Yeah, but
maybe
the thing
it'll become the latest and greatest thing.
Yeah, the thing is that it was like rather downplay, you know.
Yeah.
Rather than double up, it was supplying 30%, which is okay, you know. For us, it's okay, but for the poor people. You understand? Because we are staying in a house where they are staying in villages, you know.
Yep.
Yeah, they would need that spark gap.
Possibly.
Even for, like you say, the kids of the future, right? I was hoping for them to make a hoverboard from this spark gap or from this power surge.
Yes, I know. I'm disappointed there's no hoverboard at this point. But
Yeah, correct. That's why I was thinking it was downplayed. So I have to wait. We have to wait rather.
yes, I think we'll have to have patience with all this for sure. A lot of it, we just don't have a clear understanding yet and need to do more testing and have more results come in. And
Yeah, correct, Rick. I thank you very much, Rick. I just want to have your idea on this. Thank you.
Okay, thank you very much.
Bye.
All right, so perhaps we should wrap it up for now then. Last minute comments. Michael, I saw you're trying to send your video in there. Is there something you wanted to show? Wasn't sure whether you wanted to show something or anything you wanted to say. Saw your video trying to get in there, so.
Good night, guys. I'm gonna drop off, go get some sleep.
Yep.
Thank you very much.
Thank you, everybody.
See you next time.
See you later. Close off the live stream. Bye for now. It's now Wednesday, December 16th, 2015. Keshe Plasma Reactor Group signing off for tonight.